Hi everyone and welcome to this course on object-oriented programming in Python. Python is by far the most popular language used today, and in this course we'll learn about OOP in Python. So let's begin. Basically, object-oriented programming is not limited to any specific programming language. We apply the concept of OOP with any programming language, but for the purpose of this course, we'll just focus on Python. Alright, so first things first, what is OOP? So, what is object-oriented programming? Object-oriented programming is the way of doing programming in a better way, in a more efficient way, in a more intelligent and structured way. Okay, so said differently, we can say that OOP allows you to do any type of work that normal programming cannot do, like that normal programming methods cannot do, so you can do it with OOP. So, not only that OOP is a much better way of programming, but it also allows you to do some additional stuff which are much more complicated to do in normal programming. Alright, so so as I said, it's just a way of doing things in an efficient and organized way in which we put the relevant functions of the app in a bunch of blocks. So blocks, in other words, we call them classes. We place objects into the classes. So in this way, what's the main purpose of object-oriented programming? If we do the following, like if we place objects in the classes and if OOP is organized in a bunch of blocks. So how does this improve our work? It basically improves the style of your code to build efficient and meaningful code. So it's more organized, it's more efficient, and that's pretty much it. Like when it comes to OOP, it's way more organized and meaningful, and you can directly spot some something specific that you're looking for example. Alright, so the next question before us is why do we use it? Like, why do we use OOP? Alright, so as I said earlier, to use OOP, you don't really need like a specific programming language to adopt the OOP concept and the OOP way of doing things. You are free to use it with any programming language. You can use it with the programming language of your choice. You can use it with Python, with Java, or you can use it with any other programming language of your choice. So yeah, you can also use OOP with C# and many other programming languages. So it's really up to you. And if we use OOP, it's not because of the programming language. We use OOP because of what it allows us to do, and because of its power, and because of its organization, and because of the efficiency. That's why we use OOP. It's not because of the programming language. It's just a concept of programming. Alright, so the next question before us is why should it be used? Okay, so it should be used because when you are building a huge application, then it will have a lot of functions, and a lot of functions are relevant or similar to each other. So let's suppose you are making a calculator. So how many functions do we need to have in the calculator? There will be a function of addition, for example. There will be a function of subtraction. There will be a function of multiplication. There will be a function of division. There will be a function for the decimal, and there may also be a function for the square root, and there will also be a function of how to find the power of a number. So these functions are all relevant functions. And okay, so now what could be better for these functions is that we build a small house for them, like for those functions, where all of them are placed, and that house is the blocks. So this house that we are building to store these functions, you can see it as the blocks that we call classes. So that's how we would name it in a meaningful way, or to better say it in a programming sense, we would call the blocks, like the classes. Alright, so in other words, we call them classes, And yeah, so it allows us to organize our building process. So if we're building the calculator, we need to have so many different functions, and to store them and to organize them, we need to use what we call classes. It's like those huge blocks of storage where we are storing these functions. Okay, so the next question before us is, what will happen if you don't use OOP? So what will happen if you do not use OOP? Basically, nothing much will happen if you don't use OOP in your code. But by writing your code using OOP, the redundancy of your code will be controlled. That means that the duplication in your code will be controlled if you do use OOP. However, if you don't use OOP, your code will run perfectly and at the same level as others, but there will be no cleanness in your code. So your data will not be as clean and as efficient as like when you build your code with OOP. When it's built with OOP, it will be much more clean and much more efficient. All right, so yeah, so there will be a lot of redundancy, and there will be a lot of duplication and repetitions in your code if you don't use OOP. Therefore, if we use OOP, if we do use OOP, we will be free from the redundancies and our code will be like much cleaner. Okay, the next question that we have in front of us. So what class? All right, so a class is a place where all our functions are placed and where all our methods are placed, and that class will create an object, meaning that it will create an instance. So what is a class in short? It's a blueprint which then can be used as multiple instances for an app. For example, you can make a list by typing list, then brackets or curly brackets, and you write any digit or word with the English alphabetical words, and then you make it equal to any variable. So it will become your object, or will become an object of that class, or an instance of that class. So in the next lectures, we'll see them in more details. We'll see them like practically and implement them by using Python. But for now, just understand that there is a set of methods inside the class that we can use in our own way. Okay, so the next question is, what is an object and what are the methods? Like, what do we really mean by objects and methods in OOP? So as I said earlier, when you create an instance of a class, then that variable which you created was called an object. And for the method, it's like when you use the functions within your class. In other words, we call them methods. Like when you use functions within your class, we call them methods, so that they are referred to as methods. Alright, so the next question that will come to your mind is probably related to this question. What is the difference between methods and functions? So what factors differentiate methods and functions from each other? Okay, so as you can see, when you use the function in the simplest way, then that's what we call a function. Like when you use a function in the simplest way possible, then you can call it a function. However, when you use those same functions inside your class, like in your class, it has a different name, and that name is method. So you can call them methods. Okay, so let's conclude this lesson and keep in mind that when we use functions in our class, then we call them methods. So, alright, so that's pretty much it for this lecture. We covered the basic introduction about OOP. In the next lecture, we'll see and implement all these concepts one by one. But for now, like what's important is that you understood what classes are, what objects and methods are, and how we can use them. Of course, at a later stage, we'll discover and learn about more advanced topics, such as the concept of constructor and polymorphism. But for now, that's pretty much it. So we'll leave it at this stage and see you in the next lecture. Alright, so let's move on. Hi, and welcome to this second lecture on object-oriented programming. So in this lecture, we'll use the Python language, and the IDE that we are using is Jupyter Notebook. So I already created a file in my Jupyter Notebook with the name of create your first class, and today we are going to make our first class and see how we can create classes in Python. So to create classes in Python, we have a very easy way of doing it. First, we have to write class, and then we have to write the name of that class. So let's suppose we write student as the class name, and after that we see that we're not going to use any parentheses because the parentheses are used in other programming languages, not in Python. Okay, so in other languages, basically we have like different syntax of building classes, but when it comes to Python, we have a different syntax. And in this lecture, we are going to learn about it. And then we'll see like what's the purpose of this syntax. Okay, so let's write colon. So in Python, we use the colon after the class name. Now, in the next line, we have to write def, then space, and twice like underscore. And then we write init. We call this the constructor, and then again we write twice underscore, and then we write open and close parentheses, and in this parenthesis we write self as a parameter, and we are going to use like more parameters for this example. Okay, so for now, like what's the purpose of taking parameters? Let's try to understand it. Parameters are used to talk about the behavior of the next object which you want to create in your class. Which helps you to tell the class what qualities and what attributes and what methods you want in your class. So we have to define these things in the class so that it will have all the things we want as an attribute. Therefore, we tell the class through defining parameters what its object or instance would look like. Now we have created the class with the name of student. And now as we think about that student's attribute, then we should have the name of the student, and we have the roll number of the student in the third parameter, and then we also have the number and marks of the student. So for now, we'll use only these three parameters. If you want to create like more, you can create more, like you can create as many attributes as you want, but in this first example, we would focus on creating classes with these parameters. And then after that we write the colon. Okay, so now the first parameter, self, we have written in our class is very helpful in OOP, like it's a very helpful parameter in OOP. We'll discuss this parameter at a later stage, like in another lecture, but for now let's just stay focused on what we are doing. Let's just stay focused on creating our first class and on understanding its syntax. Okay, so we write self.name is equal to name, and after that you can hit like the shift plus enter, and on the next line we write self dot roll underscore num equals roll underscore num, and again hit the shift plus enter on your keyboard, and then on the next line you write self dot marks is equal to marks, and now hit the shift plus enter. Alright, so we have created our first class, right? So this is our first class basically. Now, what will this class do? So this class will help us make objects and define the type of object we want and what attributes we want in this class. So this is like a blueprint, meaning that the next object which should be created would have the same parameters as we defined above. Okay, so now we'll try to create an object and see how it looks like. So you can give any name to the object. I'm gonna write like student1 is equal to student and open / close parenthesis with the inverted comma. Then we write here Sohail 1 2 3 4 5 500, hit shift plus enter. So this is the first object that we've created. Now let's print this object. So write the object name student1, then hit shift plus enter. And as you can see in the output line, it shows you the creation of our object with the name of __main __ dot student. Okay, so if we write dot name with the name of our object and hit shift plus enter, we can see the name of our student as a result. So now student1, which we have created, is the object of our class student. So now let's see how we can create our second and third objects. So as you can see, I wrote dot name and it showed me the name of the student. In the same way, when I write roll _ num, it will show me the roll number in the output. And in the same way, when I write marks, it will show me the marks of the student. So if we want to create a second object by using the same parameters of the above class, then for that we should write in the same way. Student2 is equal to student, we open brackets, and then we write the name of the student. So it's here like Usama 1 2 3 4 5 700. We close the brackets and then we hit shift plus enter. Now let's check this by writing student2 dot name, and as we hit shift plus enter, it will show us the name of the second student, like of student2, which is Usama, in the output. So this is our second object. Okay, then let me tell you why we should create a class or an object. So we create classes because this helps in reducing the amount of code that we have, and also because what we're doing is not possible with the help of functions. Alright, so if we create a blueprint for each student class, then we will use it for as many objects as we want, and there is no need to write or build another class for the same attribute entity. That's how it helps in reducing the code redundancy, as we have discussed in our previous lecture. And in the classes, we can also add as many parameters as we want. And if we want that some parameters show up with selective objects, we can do that with the help of classes. But that's not possible with functions or user-defined functions. So that's the power of the classes. It's so powerful because it can give you like so many information in such an efficient way. Alright. So as you have seen, we can get anything from the class, like the name, the roll number, the marks, as per your requirement. We just have to write the object's name and its attributes. So as you saw through this class student, we have created an object, student1, whose marks are different from our second object, student2 marks. So I've created only two objects through this class as an example for you, but you can create as many object as you want from this class. So to conclude this lecture, I can say that we now understood the concept of classes, how we can build classes, and how to make an object from these classes. So in the next lecture, we'll talk more about classes and dive deeper. Alright, so let's move on. Alright, so in this lecture, we'll dive deeper into classes and explore them in detail, like to see how powerful they are and how we can use them in their full capacity. So, as you saw in the previous lecture, we covered the topic of class creation, like how to make a class. That's what we learned. Then, we also learned about like how to make an object in the class and how to print the attributes of the object. In this video, we'll study the four most challenging things while making a class. Like these things that we'll discover are quite confusing and they are challenging for students. So for someone who's a complete beginner, yeah, it is obviously challenging, and we'll try to demystify each and every concept that is tough for beginners to grasp in this lecture. All right, so the first thing is like, what is init? The second thing that we'll learn about is like, what is self? The third thing is it important to match the variable's name with the attribute's name? And the last thing that we'll cover is like, can we change the class's name from a capital letter? Like the first letter of the class, can we change it from a uppercase to a lowercase? So the first question before us is like, why do we write self? What is the use of self? So let's answer this question. So why do we do what we do with self? So because it is the convention to use self. That's like the convention. You can write any other name if you want, but usually we use self because it's a convention. So let's suppose that we write ABC here. We also write ABC here and here as well. So will it work? Let's see. So to check this, we need to make an object with the name of student1, which should be equal to student, open brackets, Suhail Khan, 1234, 500, and hit shift plus enter here. Okay, so on the next line, let's see if it prints our name or not. So write student1.name and hit shift plus enter. And yeah, so it works. And as you can see, it works. Yeah, so it prints the name of the student. So what does this mean? It means that it's not necessary to write self, and we can write any other word if we want to, because its purpose replaces the name of the object. So yeah, you can write basically any other word that you want. Okay, so what happens now when our program runs with this student1 replacing this ABC parameter? So whenever a new object is created, the name of the object is placed here, and also here, here, and here. So for more clarity, let's replace this with object1 here, and here, and here as well, and also here. So object1.name means whatever the object's name is, I will write here with dot name, so it returns me the name of the student. And likewise here, like whatever the object's name is, I write here the dot roll underscore name, so it returns me the roll number of the student. And the same goes for the marks here, so it also returns the marks here. Now you understand that when I run this code, it works. So hope now that you're not confused with the self keyword that you see in front of you. Okay, so let's change it back to self. Let's change it back to self, like what is the original convention and what we used to do in OOP. So I changed the name only for your understanding. I'd like to see that it's not mandatory to have it. Otherwise, the most efficient way of doing this is with the self keyword. So let's go to the second question now and tackle our second problem, or our second point of confusion. So is it important to keep the name the same here and here? And the answer is no. It's not necessary to keep the same name of attributes and parameters. You can write student name here, and you can write roll underscore number here. You can also replace these marks with student marks. But now, if I want to print the name of the student, so as I said before here, we need to write the object's name, and after the dot, the name of the attribute here. So it will be written as student1 dot student name, and then we hit shift plus enter. Then it will print the name of the student. Okay, so if I want to print the marks here, then it should be written as student1 dot student marks, and after hitting the shift plus enter, it will print student marks. So if I create another object with the name of student2, and with the parameters student2 is equal to student, open brackets, Usama 2234 700, now this is the object of student2 with different information. If I want to know the name of student2, then here I need to remember the attribute's name. With the help of that, I print the student2 name. Okay, so the reason why we keep the name, why we keep the same name of our attribute and our parameters is because it would be easy to remember. If you don't want to assign the same name, it will also work properly. but for, for easiness, we keep the same names. If I write ABC here, it will also work. So let me do it for you. As you can see, it's working. But this ABC has no meaning in our program. If somebody else sees our program, they will not understand what's the purpose of ABC here. That's why we try to use conventions, and we try to make it easy, and we try to stick to some regular stuff. Okay, so you can write marks or student marks here, and it's up to you. But you have to write a name that shows the meaning of our program. Otherwise, it will be very confusing for others to understand. All right, so let's now conclude this lecture. So basically, we discussed, we dived deeper into the topic of classes in this lecture. We dived deeper into classes. We explored it in detail, and we understood the concept of self and attributes name. So hope that everything was super clear to you now. And that's pretty much it for this lecture. And now on to the next one. Hello and welcome to this new lecture on object-oriented programming. So in this lecture we'll cover the remaining topics of the previous lecture, and we'll also do an exercise on the product class with the attributes like product name, brand name, model name, and price. So we'll do this exercise so that you can better understand the use of classes. Alright, so we'll also see that it's possible to add more parameters except for self in the class from this exercise. In the last lecture we talked about self and the effect of changing attributes and parameters names. So today we'll first cover the remaining two topics. The first one is the effect of changing capital to a smaller letter of a class name, meaning whether the class keyword is case sensitive or not. So this, as we saw earlier in the parameters, it doesn't affect which name we should use, and the same goes for the class name. So it doesn't affect if you write it with small letters or capital letters, or if you assign another name to the class. And yeah, so I hope this is clear to you by now. And as we saw in the previous lecture, it doesn't matter. Okay, and you can check this by yourself. Just try to practice and you'll see by yourself that it really doesn't matter. Okay, the second topic remaining from the previous lecture is how many attributes can we make. So is it possible to create more attributes than parameters or not? Okay, so first make the class with the name of product, class product, and hit enter. And in the next line write def init. So what is the purpose of writing this def init? So this is the constructor. In other programming languages, we saw that the constructor was written as a constructor. But for now, we are using Python for object-oriented programming. Therefore, in Python, we write the constructor as def init. So this is the way of calling a constructor in Python. And we then open and close the parentheses, and we pass the parameters in it. So the first parameter, as you know, is self, as we saw in the last lecture. Now we pass other parameters in between the parentheses. So the first is product name, and then the brand name, and then the model name, and then the last one is the price. Then after we close the brackets, we put a colon, and then we hit enter. So these are the 4 parameters we assigned to our product class. In the next line, we write self.product underscore name is equal to product underscore name. So as I taught you, the purpose of writing this in the last lecture. So, okay, so yeah, now we can hit enter. In the next line, we write self.brand underscore name is equal to brand underscore name. We hit enter. And in the next line, you write self.model underscore name is equal to model underscore name, and we then hit enter. And as we covered in the last lecture, it's not important to write the same attribute name with the parameters. So for the representation, we give here different names. Alright, so write self.model underscore price is equal to price. Alright, and as you see here, what it means is the full name. So it represents what we want. Where we want the price of the product, so it becomes very easy for you to understand what we are exactly doing. And like above, we wrote product underscore name is equal to product underscore name, meaning that the full name represents the purpose of the attribute. Okay, in the price attribute, we can also write ABC, but it doesn't represent its purpose. Okay, so here I wrote the wrong spelling of the self. Okay, sorry about that. So we can write ABC here, but it would be difficult for us to represent the meaning and purpose of that ABC attribute. So for us, it would be nicer to write price here. Okay, now hit Shift plus Enter. So here we have created our class. Now create our first object of laptop type. So laptop is equal to product. We open and close the brackets. Then we write the product name laptop. Then the brand name Dell. Then the model name M4800. And at the end, we put a price of 55,000. So this is for a laptop. Okay. Now create one more for the mobile. So mobile is equal to product. Then the same here. We write product name mobile. Then the brand name Android. Okay, sorry about that. So we'll put here Samsung. Then here the model name. It would be, let's say, A7. And at the end, we put the price, which is like 50,000. And then we hit Shift plus Enter. Okay, so sorry about that. I missed out the comma. So here I'm adding the comma. And here we go. We now can press Shift plus Enter. Okay, so now here, if you want to know about the price of a laptop or model of a laptop, in the next line we type laptop.model_name and we hit the Shift plus Enter. Okay, so sorry about that again. I mistakenly spelled this. So now hit Shift plus Enter again to run your code, and here we need to run all the lines of code. Okay, and as you can see, it works perfectly now. So you got the model's name of the laptop. The same one goes for the mobile phone model's name. And as you can see, we got the model's name of the mobile phone. So now, as I mentioned in the question above, we build only these, like 1, 2, 3, 4 parameters. So can we add like more attributes than 4 here or not? Let's see. So the answer is yes. We can create more attributes. So there is no restriction in creating more or fewer attributes than parameters. So if you write here self.full, okay, self.product, self.product name with price, and we do it, we say it's equal to product underscore name, then we concatenate it with the plus, then the price, plus then the price, okay, and then we hit Shift plus Enter here. And as you know, in Python we can concatenate 2 or more variables. Now run all the lines of code. Sorry, here I mistakenly wrote the quotation marks. Okay, so I think it's the issue of the concatenation. So yeah, right, so it's the integer cannot concatenate with the string, so that's why this error occurred here. So we changed the price into model name for both sides, and now we run all the codes by hitting Shift plus Enter. We now have a new attribute that we made by merging the above 2 parameters, and as you can see, these parameters are not present in our above 4 parameters. So this is our 5th attribute. Now let's see if it's going to work or not. So type laptop.product name with model and hit Shift plus Enter. Now we can see that it shows us laptop M4800. Likewise, if we do the same for mobile, so type mobile.product name with model and hit Shift plus Enter, and it works now. So hope you enjoyed this class and understood classes and their attributes in depth. In the next class, we'll cover more about classes and the methods of classes. Alright, so let's move on. Alright, so hi and welcome to this new lecture on object-oriented programming. This is our 5th lecture on OOP. So in today's lecture, we are going to learn about methods and see what they do. So in object-oriented programming, we use methods a lot. So first of all, we have to see like what's the purpose of methods outside object-oriented programming and where they would be used more. So as we know, if we create a list with the name of L1, so L1 is equal to a list of 1, 2, 3, 4, 5. This is the list that we've created. Now in this list, we've created an object, which is L1, or you may call this an object. You may call it an object because this is in the class of list. So you may call it an object because this is in the class of list. So here, the L1 represents the list of numbers. Now, if we want to exclude the last number from it, we have to use the pop method. So pop is the method that is used to extract the last number of an object or a list. So here we write list.pop L1, as you know. So list is the class and L1 is its object. Okay, so now hit Shift plus Enter, and as you can see here, it pops out the last number from the list. So for confirmation, let's check the current elements of the list by simply typing the list name as L1 and pressing Shift plus Enter. So it shows only 4 elements because the last one pops out. As we can see here, L1 is an object or a list of numbers, and that pop brackets is a method. So here pop is a method because when we use it with the object, it performs some kind of function. Like here, it excludes the last number from the list. Therefore, when we have a function within our class, we call it a method. So this is a predefined method that we've used here, but we can also build our own methods in classes. So now, we'll see how we could build our own methods and what do we call them. So let's see. Let's start with the new code. Okay, so first type class student, now hit enter, and on the next line call the constructor by writing def init self. So you already know why we are doing what we're doing. You know why we are writing self in our code, because if we want to replace any object, then our program can replace it with self. So now also give the parameters of name and age and marks, then put a colon, after that the closing bracket, and then we can hit enter. So okay, write self.name is equal to name, hit enter. Write self.age is equal to age, hit enter. Write self.marks is equal to marks and hit shift plus enter. On the next line create an object of s1 is equal to student, we open brackets, okay, and we put the quotation marks here, and we place the value of all the parameters except self, because Python would automatically replace self with an object name of s1. Therefore, we don't need to write that. Okay, then write the values. So the name here is Sohel, the age here is 24, and the marks 500. So if you want to get the name, you know how to get it. Simply by typing the object name and its attribute s1.name and by hitting shift plus enter. So we can see the name as output. Now we will make a method, so we have to go up and write our code here because we are going to create a new method. Therefore, we need to create a constructor for creating the method. It would be built the same way as we built our constructor above, by writing def and then writing the name of the method, which would be result. Now we have to pass its parameters in the brackets. So the first parameter should be self, because as I said before, the criteria of the method creation will be the same as the one for the constructor. So here self will do the same work as it did in a constructor. Then we add a colon and then we hit enter. Okay, so now in our method we are going to create our condition with a if statement. This condition will define that if a student's marks are above 500, then he or she would have passed. So if it's not above 500, then we can say that he or she should have failed. So in this method, we'll see how to use these attributes. As we pass self as a parameter, it helps us to provide these attributes. We need marks to check greater than or smaller than 500. So to do that, we'll write self.marks is greater than 500 and we hit enter. So here we use the condition that if the marks are greater than 500, then it should return pass. Otherwise, it should return fail. So this is a simple method that we've created. Now hit shift plus enter and run the code. Next, go to line input 22 and check whether it's working or not. So here we write s1.result brackets. Now we have to write the parentheses because it's a method and it's the representation of methods. So that's why we have to put the parentheses, because this is a method. Okay, so now press shift plus enter and it shows the result of fail. So above we have given the condition of greater than. Like what if we give the condition of greater than and equals to? So it shows pass as a result, right? Okay, yeah. Alright, so in this lecture we talked about methods and how they work. I hope that by now everything is super clear to you. So in the next lecture we'll learn more about methods, but for now that's pretty much it. So let's move on. Hello and welcome to this new lecture on object-oriented programming. In this lecture, we are gonna talk about methods in OOP. So we have covered a part of the topic in our last lecture, but today we'll dive deeper into it and we'll do an exercise on this topic as well. So we'll actually do 2 exercises regarding this topic. So in the first exercise, we will not need to pass any parameters into the functions or methods, so we'll simply create those functions in which there is no need to pass any parameters, and we'll also see those functions in which we need to pass parameters. So we'll see in this lecture how we can use them. Okay, so we'll speak about these 2 things in 2 parts so that you can better understand the topic. In the first case, we'll make a class that includes a student's marks and a student's name, and after that, according to the student's mark, we'll show their result, whether the student passed or failed his or her exam. So we'll create 4 to 5 objects with different students' names and marks, and by using a for loop, we'll see which student passes their exam or fails the exam. And yeah, so that's the goal of this lecture. So let's create a class with the name student. And as you already know, like how to make a class, so you should just follow the normal procedure that you studied before. Now on to the next line. Create a constructor by writing def init self name marks, then hit enter. And on the next line, we'll assign our variables to the parameters like self.name is equal to name, hit enter, and self.marks is equal to marks. Now press shift plus enter and create an object on the next line by writing s1 is equal to student Sohel 400. So we created an object with the name and student marks. Now let's create a method, but first we have to check the student's name to see if we get a student name or not. Alright, so yeah, I'll be going to create a method which will show us the result of the students who passed the exams or not. So by writing def result self, as we saw earlier. So now press enter and use the if statement on the next line and write if self.marks is greater than or equal to 500, then hit enter. And on the next line write return pass, hit enter. And on the next line write else return fail. So this is the type of exercise you have done earlier, but in this exercise you are trying to use like real life examples to better understand what's going on. Okay, so to do that, let's make more objects, make 5 copies of the first object and change the object's name, student name, and marks respectively. So you can give any name that you want according to your preferences. So let's make a list of these objects. And yeah, so to access them easily by writing like student underscore objects is equal to S1, S2, S3, S4, S5, S6, and press shift plus enter. Now let's check which students pass the exam and which ones do not. So to do that, we use the for loop and assign our list to the x variable by writing for x in student objects. Now press the enter, and in the next line we use the if statement. So if x.result is equal equal pass. So for that we have to make 2 lists. The first one is for the past students, like the one the ones who pass their exams, like the students who succeed, and the second one is for the students who fail. So let's make P and F small here. So now we have to create a dictionary of students underscore result is equal to curly brackets. So now we have to store the results of the past students, like of the successful students, in the past students list. Okay, so to do that, write past students dot append x name. Now hit enter, and on the second line we'll make an else condition. But before that, let's put the name of our list into the dictionary. So students underscore result past students is equal to past students. Hit enter, and after that write the else condition and hit enter, then copy and paste the above two lines after the else condition. So now here change the past students into the failed students here, and also here, and then press shift plus enter to run the code. So now let's call our dictionary and run it. So here you go, it shows the result of all the students according to the failed and passed students. Alright, so in this lecture you have seen like how object-oriented programming helps us to perform a longer task in a shorter way. So that's pretty much it for this lecture, and now on to the next one. Hello and welcome to this new lecture in which we'll learn about methods in OOP by doing another practice activity. So it's going to be the second exercise. So in the last exercise, we covered methods with a real-time example. So in the previous example, like we have created a method in which students pass and fail according to their marks. And then we put them all in a dictionary and a list, and then we printed them. Like we printed all of the students' names according to their results. In this lecture, we'll make a product or a list of products that contains all the products' names and prices. So a new thing we'll add in that method is, like, if we want to give any discount to a customer or retailer, we'll make a program allowing us to give our customers discounts according to our preferences. So let's see how to make a method that passes the arguments. Okay, let's make a class with the name of the product, class product, and hit enter. Then you have to call a constructor, so def underscore underscore init underscore underscore self product name price. So for this example, we only need these parameters. After building the constructor, hit enter. On the next line, let's assign variables to our parameters. So by writing self.productName is equal to product name, and then we hit enter and write self.price is equal to price. We build our class. Now the next line, let's make an object name with laptop is equal to product. Laptop, like laptop is equal to product, and then inside the brackets laptop and 55,000. So we have put the name and the price of the product. So let's check if it's working or not by getting the laptop price. So laptop.price, and yeah, it's showing us the results. Okay, so now build a method that passes the arguments in it by writing def discount self comma the discount value, and hit enter. So here we are building a function which gives a discount to customers according to our preferences. In the following line, we write our discount formula, which is discount amount is equal to self.price divided by 100 times ds count value, and we hit enter. Now in the following line, we calculate our final price by deducting the discount amount from our original price. So final underscore price is equal to self dot price minus discount amount, and after that we hit enter. Okay, so on the following line we return the value of the final price by writing return final price. So now run all of the code by pressing shift plus enter and check if our code is working or not by writing laptop dot discount brackets 15. So in the parentheses write your preferable amount in percentages which you want to give to your customer. Okay, you can see the result in the output line. In the above code, before return, we'll write int final underscore price. Then it will not show the dot zero after the discounted value. Now, if we want to give a 25% discount, we can also do that simply by replacing the 15 in the brackets by 25. So in this lecture, we have seen like how we can make a method in which we pass our arguments according to our preferences. In this lecture, we've used the discount method and passed our own argument in it, which puts the value here. And this whole method works like this. So this is a common method which we built to calculate the discount for customers. So first we create the formula for calculating the percentage of the discount amount, and then we subtract the discount amount from the actual price, and after that we return our final price in integers. So we use the integers because it doesn't show the decimal point after the actual value in our result. And we can also change the value of the parameter. So we can also give a 5% discount to users. We can also add more products to our product class. Like here we add a mobile object in our product class with the name mobile and price 40,000. Mobile is equal to product, brackets, mobile 40,000. And then we press shift plus enter. Now you can check it by writing mobile.price, like whether our object was created or not. And yeah, so as you can see, it works perfectly. Okay, now if we want to check out the discount function, or if we want to give a discount to our customer, we can simply do mobile.discount brackets 10 and we hit shift plus enter. In this lecture, we basically covered methods in which we pass arguments according to our preferences. So that's pretty much it for this lecture, and now on to the next one. Lecture 8. In this lecture, we'll study class variables. So it's the primary function of object-oriented programming. With the help of class variables, we'll write better codes and make them more efficient. So class variables solve our two issues. Which are the two issues that I'm talking about? So the first issue is, like when we create a class or an object, we have to give or assign arguments many times in our program. But with the help of this, we can write shorter codes and do it efficiently. So it helps us to overcome the redundancy of our code. Okay, and the second issue that occurs in our code is that it consumes more memory because of the repetition of assigned variables or arguments. We therefore have to find a solution to this problem, and class variables help us in that. So now we'll understand it practically by performing some tasks. So we'll make a class, then pass some parameters, values in it, and we try to understand like the factor of redundancy. Now make a class of class student, then hit enter. Okay, then call the constructor here, so def init, self, name, age, marks, total marks, hit enter and assign variables to our parameters. So self.name is equal to name, hit enter, and self.age is equal to age, press enter, and self.marks is equal to marks, enter, and self.total underscore marks is equal to total underscore marks. So press shift plus enter. Now, on the following line, we'll make an object for this class with the name of S1, which is like S1 is equal to student. So hell 24, 500, 1000. Now make 5 copies of this and change the name, age and marks respectively and keep the total marks the same. So now, as we talked about the first issue before, we have to write the total marks which are the same for every student, every time in every field. So one solution for solving this issue is that we can assign a direct value to our parameter. But this is not the best solution. So the best solution for this is to assign a variable or a class variable. So insert that value in a class variable and call it by its variable. So we can use it as many times as we want in our program. There is no restriction on it. So now we are making a class variable simply. Like as we made earlier, so total underscore marks is equal to 1000. Now I can remove this from here and also from here. So how can we call it? In the parameters. So to do that, we have to call the class name here, and after that we call the attribute name, so student dot total underscore marks, so we can remove the total underscore marks from every object. Okay, now run all the code again, and let's check if we can get the total marks by calling it with s1 dot total underscore marks. So yeah, we got it. And as you can see, I didn't pass anywhere the total marks variable, neither in the object parameters nor in the constructor. So now we can call this class variable as many times as we want in our code. If we made another method with the name of teachers, we can use that class variable in that method, in the method as well. So the conclusion of this lecture is that we have studied class variables and how we can use them. So we've seen how it helps us to reduce the redundancy in our code. In the following lectures, we'll do 2 exercises on class variables. The first exercise would be about specific class variables. So you'll understand that by doing real-time examples and by building 3 to 4 methods in our program. And the second exercise will be about, like, if we want to change our class variable value at any time, how could we do that? So for example, at some point, we don't want to have like 1000 total marks, but 900. So how could we do that? As I said, if we want different total marks for our teachers method, so we can do this, and we'll learn about it in depth in our next lecture. So that's pretty much it for now. I hope that everything is crystal clear to you, and let's move on. Hi, and welcome to this new lecture on object-oriented programming. So in this lecture, we are going to look at the significant topic of class variables in classes. Alright, so in this exercise, we'll make a class with the name of a circle and pass the radius and pi values in its parameters. And after that, we'll make 2 methods. In the first method, we'll find the circumference of the circle, and in the second method, we'll find the area of the circle. The purpose of this exercise would be to find out the usage of the class variable and how much it would be efficient for us to use a class variable in our code. Also, like, why would it be effective for our coding style? So let's start by making a class with the name of a circle, so class circle, and then we hit enter. Then we'll call our constructor and pass 2 parameters of radius and pi, so def init self radius pi. Then on the next line we write self.radius is equal to radius, and then self.pi is equal to pi. Now hit shift plus enter. Okay, so now here we'll make an object with the name of c1. So c1 is equal to circle 23, comma 3.14. Now make another object with the name of c2. So c2 is equal to circle 24, 3.14. And as you can see here, both objects have the same pi value. So first, let's check if our class is working or not. Okay, alright, so it's working for c1, and for c2 it's also working. Now, let's make 2 methods here. So the first one is for the circle circumference, which should be like def circle underscore circumference self. Now hit enter and create a formula for the circle circumference, which should be formula underscore circumference is equal to 2 times pi times radius. And as you can see, we have to take the values of self.radius and self.pi from the above code and place pi and radius as self.pi and self.radius. So that's why we call self in the parameter of the second class, because we want to call it from the above class. So now hit enter and return, or you can change the name of this into value underscore of underscore circle underscore circumference, because it will be meaningful and understandable. So let's change this here as well. So let's make one more method for the area. So def circle underscore area self, then hit enter. In this line, we'll write the formula of area. So the area is equal to pi times r to the power of 2. So we write this as area is equal to self.pi times self.r times 2. So on the next line, we'll return the area, which is return area, or change it in small letters. Now hit shift plus enter and run all the code. So let's check the circle. circumference here by writing c2.circle circumference, after which I hit shift plus enter. So yeah, it's working. Now let's also check the area of c1 by writing c1.circle underscore area after hitting enter. So we have the following result. Now, what is the problem in this code? The problem is that we have to write 3.14 several times. So the solution to our problem is that we have to declare a variable and assign the value of pi to it. Then we remove pi from the parameters and remove this line too. So change this self.pi into circle.pi and this one too. Now we don't have to write like 3.14 here. We only have to pass the radius value here. So now run all the code again. Yeah, right. So it runs perfectly, as you can see. Okay, so the conclusion of this lecture is that we can use our class variable in more than one method. So here, if we need to change the value of pi, we can change it easily by changing the pi variable. We all know that pi is the standard value, so we cannot change it. But what if we have another situation where we want to change the value after some time, like product price or any other thing? So I can easily change it from here, and it will work in our code. So this is the professional way of doing programming. It helps in reducing the redundancy of the code. And as you can see from here, we wrote like 3.14 multiple times. So it will create like repetition in our code, but class variables, they save our day. Alright, so hope you learned a lot in this lecture and found it helpful. So that's pretty much it for now, and let's move on. Hi and welcome to this new lecture on object-oriented programming. In this lecture, we'll cover the technique of objects, and after that we'll do an exercise on the product class which is related to this. So we'll make a program in which the user can describe the products on which he wants a discount to be given to customers. So it means that we have to decide whether we want to use our class variable or whether we don't want to. Alright, so we'll also change the value of our class variable. So yeah, in this lecture we'll see the techniques of the object and cover an exercise on it in the next lecture. Okay, so let's start by making a class with the name of the laptop, so class laptop. Then hit enter and call the constructor by writing def init self name price. I'll pass only two parameters in it, name and price. Hit enter and assign variables to our parameters. Self.name is equal to name and self.price is equal to price. Now hit shift plus enter. Next, we'll create an object with the name of our laptop. M6600 is equal to laptop. M6600 55,000. Now hit shift plus enter and create another object with the name of M4800 and okay, so yeah, M4800 is equal to laptop, M4800, 55,000. Now hit shift plus enter. Now the technique I've talked about earlier is that later in our program, if we think that some variable is missing in our object and we need to add them for some products, like some extra category or field, so that's how we use it. So okay, let's suppose we have a feature of Bluetooth in M4800 laptops only. So therefore we have to add a new parameter to it. So let's first check what attributes are present in our class by writing the object name with a dictionary. So we use a dictionary to store an object's attributes. M4800.dict and press shift plus enter. As you can see here, it prints all the attributes here. Okay, but now I need to add a new attribute to this object or dictionary. So for this, we simply write object name and the attributes in key and value pairs like this. So M4800.Bluetooth is equal to yes. Now hit shift plus enter to run the cell. Okay, so let's see now if the attribute was added or not by writing M4800.dict and press shift enter. And then it shows all of the attributes, including the Bluetooth attribute that we added recently. So this is the way of adding new attributes to our existing object. Hope that you understood what we did and that everything is super clear to you now. So these are the things that we're gonna use in our next exercise, and that's why I described them in this lecture, so that it would be easy for you to understand what we're gonna talk about later on. And yeah, so basically I'll be using them in the next exercise, and it's very important for you to have a good grasp and understanding of what we're gonna talk about. Alright, so that's pretty much it for this lecture, and now on to the next one. Alright, so hi and welcome to this new lecture on OOP. Alright, so in the previous lecture we discussed about object techniques. In this lecture we are going to do the exercise we talked about in the previous lecture. So the code is the same as in the previous lecture, and we will continue what we built previously in this lecture. So first we'll make a function of applying the discount by writing def apply discount self. Okay, so now one question arises here. What if we want to give some percentage discount to some laptops and a different percentage to the remaining laptops? So for example, I want to give a 10% discount to M6600 and a 5% discount to M4800. How can I handle this? So for this situation, we'll use our class variable by writing discount is equal to 10. If I want to give a 10% discount to the M6600 laptop specifically, then we have a method of assigning a discount value in the discount formula, which will do our work. So for this, we have to write the discount formula, and for creating that, we'll write discount underscore amount is equal to self.price divided by 100 times laptop.discount and hit enter. So here we'll calculate our final amount, which we get by the formula. Final amount is equal to self.price minus discount underscore amount. It will subtract the discounted amount from the original price. Okay, and now we'll return the final amount by writing return final amount. Now run all the code by pressing shift plus enter. Okay, now I'll use the apply discount method with M6600 by writing M6600 dot apply discount and by hitting shift plus enter. So we'll get our result. Now I'm applying the same apply discount method with the M4800 laptop. So let's see if it works or not. Alright, so it works perfectly. But what if I want to give a 5% discount on the M4800 laptop? So how can we do that? If I can change it here, it changes everywhere. Like we use discount value, but I don't want to change that, so I'll keep it like this. The solution is, if you have to add some other values in the discount variable, then we assign it here in this line like that. So M4800 dot discount is equal to 5 and press shift plus enter. Now I want to check if it was added to our dictionary or not. So copy and paste this M4800 dot dict and press shift plus enter. As you can see here, we added discount with the value of 5. Now I want to check if this affects my other object, because we want to avoid this, like we don't want to have this situation. So to check that, simply type here M6600.dict and press shift plus enter. Alright, so the discount variable was not added here. The discount variable was only added in this M4800 object. We now have to understand one more thing, and that is we have learned like how to use our variable in our class like this, but instead of that, like what if we write self here? So then it will be more beneficial than the previous method, because it will see if within the object or method there is any discount variable present or not. So if it's present, then it will take that value, and if not, then it will take the value from our global variable. Now let's check this practically by applying a discount to our M6600. So here, write M6600.apply discount and press shift plus enter. It's showing us the same discounted value of 10%, which we applied earlier. And if the same thing applies to M4800, then let's see what it will show us here, because I already added here like 5% for the discounted value for M4800. So it also has to be the same as before, because we use self here. So it would work intelligently here. It sees that here, if this object has the variable of discount, then it will pick that. If it doesn't, then it will pick this variable. So, did you see any discount variable here? No. So then it will pick this discount variable. Or, if it has this one here, then it will pick this class variable because we used the self keyword here. So press now Shift plus Enter, and here you go. So here I haven't run all the cells, so we need to do that. Now run all the cells by pressing Shift plus Enter, and here you go. As you can see, it works properly. So it gives the price after subtracting a discount of 5%. So to better understand, let's make another object with the name of M6600 and put values in it. So M6600 is equal to laptop M6600 55,000. Now let's change the laptop name to 77110, and the price should remain the same. So press Shift plus Enter to run the code. And alright, so for this laptop I want to give only like a 3% discount. So to do that, I'll write M6600.discount is equal to 3 and press Shift plus Enter. Now let's check if it's working or not by writing M6600.dict. Okay, so it's showing a discounted value here. Sorry about that. So I made a mistake here. I wrote the wrong object name. So let's change it to M7710 everywhere. And we run all the code again. So now we would apply the apply discount method to our M7710 object. So enter here M7710.apply discount and run the code. It shows the value. So now run all the cells again. Okay. In this object, we do not have any discounted value, so it picked that from this class variable. Now, whenever we don't put a discount variable in our object, it will take that from the class variable. So now here for M4800, we have told this that it has a discount of 5, so it's perfect. So after that, I created another object named M7710 and gave a discount of 3%. It also works properly. So now, let's make an object with the name of M600 in which we will not give any discount. So let's change the name of the object here, then hit Shift plus Enter. So on this line, I'm applying the discount value is equal to 0. So now let's check this by writing M6700.apply discount. Alright, so it shows the same price as the actual price because I gave 0 discount here. I hope that you understood what we did in this lecture. So in this lecture we basically learned about class variables and why we should use them, and also we used the different techniques which we've learned earlier regarding this topic. So now the last thing that we'll see in this lecture is serial numbers. So how could we implement serial numbers automatically? So to do this, we first have to declare a variable with the name of SNO and make it equal to 0. Whenever we create an object, it calls our constructor. So now what we'll do here is that we'll write laptop.sno plus equal 1, and then we hit enter. On the next line we write self.sno is equal to laptop.sno. Now what happens here is that we've declared SNO is equal to 0, so every time when our code runs, our program will use this code. So this is what every time, what will happen every time. So it will add like one number to the previous serial number, and then it will add like this number to the attribute, to this attribute. So now run all the cells again. Okay, after that check all the objects in our dictionary, so by placing them in a sequence. Okay, so we can check them according to their serial numbers. Place all the objects dictionary in separate cells. So now run the cells, and as you can see here, everything will be displayed according to the serial number. So I hope that it's now clear to you I hope like this just cleared all the doubts that you had about adding serial numbers and about this exercise in general. So keep learning, keep practicing, and see you in the next lecture. So let's move on. Hello and welcome to this new lecture on object-oriented programming in Python. So in this lecture we are going to see two common issues that occur in classes. So what are these issues and how can we solve them? These are the topics that we're gonna see in this lecture. But before proceeding any further, we have to create an object and print its attributes. Then we'll see what issues occur in the class and also we'll try to solve them. So these issues may occur in our next lectures, that's why we'll see them in this lecture. Okay, so for now, let's try to understand that when they occur, like when they will occur, we'll solve them easily. So let's create an object with the name of phone1 like this. So phone1 is equal to phone Nokia 11005000. Now hit shift plus enter. Okay, so this is our object. One more thing I want to tell you is that I picked this code from our previous lecture and added this line here because of the issue that you want to see occur throughout this code. So we want to see it occur throughout this code. Okay, now print all the attributes of our object. So like this, phone1.brand, then hit shift plus enter. Okay, so it works perfectly. Now in the next cell print phone1.model underscore name and run the cell. Oh, so there is a spelling mistake here. So yeah, now it works. Again, in the next cell print phone1.price and hit shift plus enter. It also works. And then we have to print phone1.complete underscore specification, and as you can see above we have 4 attributes here. Okay, now run the cell and it works. So this is the result. Okay, so what are the issues? The issues are that if a user enters a negative value of a price, and if I run this, then it works perfectly. But as you know, price shouldn't be a negative value. So we can solve this issue. But how can we solve it? Let's see. Yeah, like we'll see it later. And the other issue is that if we change the price at the runtime, then it also needs to change on the complete specification attribute, meaning that if we change the price of the phone to minus 7,000, like phone1.price is equal to minus 7,000, then run the cell and print the price in the next cell by writing phone1.price, and as you can see it changes from minus 5,000 to minus 7,000. But if we check a complete specification, then the price has not changed, even after updating here, so it does not show the minus 7,000. Okay, we are going to solve these issues. So the first one is the negative value in the price, and the second issue is when we change the price, it doesn't impact the complete specification attribute, even though I change it from here. So it also shows the result of minus 7,000, but in the complete specification, it has not changed. So we have identified the problems. Now let's try to solve them. Okay, at first we'll solve this negative price issue. So there are 2 methods to solve this problem. Let's see how we can do that. So the first method is that we can use the if and else statement here, like this. Here we write if self.price is greater than 0, then press enter and write self.price is equal to price, then press enter and write the else condition here, so else colon, hit enter, and here we put our price is equal to 0 like this, so self.price is equal to 0. Okay, now run all the cells and check if it works or not, and as you can see the price becomes 0 here. So whenever a user enters a negative price, it returns us 0. Okay, so here we can also run these cells to see whether it's working or not. Okay, so we change it to positive price 7,000, but our complete specification attribute doesn't update here. So this is the second issue which we need to solve. So before going into this issue, so let's see another method of solving our negative price issue. So comment this code here and above. So we write like self.price is equal to max price 0. Yeah, like we commented. So on this line we used the max method and passed our price and the 0 value in it. Now what this method will do is that max method checks the value of price and 0 which you have passed in its argument and print the maximum value from them. Let's check this by running all the cells. Okay, so as you can see here, in the phone1.price, it prints 0 because we have passed a negative value of minus 5,000 in its parameters. Okay, so this problem occurs here again. So this is the second way of solving this issue of negative price. We may also generate errors here, but for now, I'm okay with that. So now let's go on to the second issue. So why price do not update in the complete specification. The reason behind this issue is that we are not running our constructor. Like if we rerun our constructor, then this value will initialize again. So this value too, and this one too. And after that, it will update the price. But the better way of doing this is by creating a method. Then that method will update all the values before running the code, and it will show the updated value. Okay, so comment this line for now and create a method for this by writing def complete specification self. So we've passed self because here we want to call these attributes. So now let's return this statement like this. Return f. Okay, self brand, self model name, and price is self price. Okay, so this is our function that will return here. Now run the entire code, so it's working perfectly so far. This is the result of a negative price problem, which is accurate. Now, we are updating our price here. We've commented out this line of code, so this is our function. It's not an attribute. So here, also add brackets, then run the cell, and as you can see, it's working now. So now let's try to add some other prices here. So phone1.price is equal to 2000. Run all of the code, and you can see that here it's updated. So this is a common issue that occurs in programming, and it causes unwanted behavior in the program. That's why we've created a function here which will update the value of the price. Okay, so we also have a second technique to solve this issue. We can use the property method here, the add property method. So it will change this function into the property. It means that we don't have to use any parentheses here. I can write this phone1.complete specification parentheses has an attribute like this. So phone1.complete specification. Now run the whole code and check if it works or not. So yeah, it's working perfectly. Okay, so you understand now the add property. Hope this lecture helped you solve these issues. Sometimes these issues can become very critical and complicated for programmers. So in this lecture we have solved our negative price issues because the price of a product can never be a negative value. And we also have seen like the update issue, which occurs due to this attribute, meaning that our price was not updated after changing the price at runtime. So we converted this into a method. Now, whenever the price updates, it will call this method and show the updated price. So this is the solution to our second issue. And we also covered this, like the add property. With the help of this method, we can use it as an attribute. So here, for example, we used it without parentheses, but this is our method, and that's why we had to add parentheses. Therefore, I used the add property decoder here so that our method could behave like an attribute. Okay, so that's pretty much it for this lecture. In the next lecture, we'll discuss the topic of inheritance. So we'll dive deeper into inheritance and explore what it means and how we can use it. Alright, so for now, that's pretty much it. And now on to the next lecture. Alright, so in this lecture, the topic that we will cover is the class method. So this lecture is very important for you, especially if you are like lost with the method that we used earlier. This lecture's method is different from the previous one. So let's begin. A method is like a function that we use in a class. So the class method helps us create our constructor. When we create a class, we have a default syntax for creating a constructor. We use this as a constructor, so def init. But in this class method topic, we'll create our constructor. So in this lecture, we'll cover the class method topic and how we can make our constructors and how we can use them. And I will also talk about the difference between classes, class variables, instances, methods, and constructors for you to understand them properly so that you don't get lost anymore. So let's start by making a class as we did in the previous lectures. So I'll briefly explain the things that we covered earlier so that you can understand this lecture better. And we will easily differentiate the constructor that we built earlier and the one that we are building in this lecture. So one more thing about class methods is that they are used in rare cases. Like some people don't even cover this topic, but we are learning object-oriented programming properly. So we'll also cover this topic because we want to learn everything about OOP. So that's why we're talking about every single topic possible. So make a class with the name laptop, class laptop, and press enter. Make the constructor the same way as we made earlier, so def init self name price. We have passed only 3 arguments here, so now on to the next line, write self.name is equal to name, press enter, then self.price is equal to price. Now run the cell, we'll make an object M6600 is equal to laptop M6600 50,000. Now hit shift plus enter. Oh, so we got an error. We have missed the underscore after init, so it should be like def init self name price. Now run the code. Here we have created our object. So now we have to print our object. Why we don't directly use print like this, like print M6600? It will show this result, but we want to print the attributes of the object. So to do that, we use this instead. We use the M6600 dot dict. Dot, like the underscores and the dict in between. So hit shift plus enter, and it will show our arguments. Now here we create our class method, but before that we'll create a method with the old syntax so that we can see the difference between both syntaxes. So write def apply discount self and hit enter. So here we write the formula for calculating the discount. So to do that, make the class variable discount is equal to 10. Now write discount amount is equal to self.price divided by 100 multiplied by self.discount. So now you know already like why we use self here, because if I want to change the discount, then it will be easy for me to change it at any point. Okay, and now on to the next line, right? Final underscore amount is equal to self.price minus discount amount. Hit enter, then return the final amount. Now run all the cells and check this by writing M6600 dot apply discount and press shift plus enter. So it shows the discounted price of the M6600 laptop. So let's make it an integer so it removes the decimal points. Okay, so now here we've created a default constructor which takes values in it and shows us the result. So it's a default constructor in which you will give values in the parameters and then show the result. But what if I have 2 types of values? One would be an integer and the other would be a full string. So I want a constructor which can show the value like this and also get the values from the string and print them. Okay, so now let's do that and see how we use them. So first try to add class method and press enter. In this line we'll give the name of our class method. So write def from string. So basically from string is our class method name. In the previous syntax, we always passed self as an argument for the convention. So we can write anything here like Sohel or, anything basically. So let me change all selves into Sohel just to check it out and run all the code again. This is only to show you that it will also work and that there is no problem by doing this. So change every self into Sohel, change it here as well, and here as well. So as you can see now, it works perfectly. And yeah, that's just to show you that I can change it, that I can change the self. So that's how it works. And there is no problem if you change it. Alright, so that's pretty much it for this lecture. In the next lecture, we'll build on what we started in this lecture. But for now, that's it. So let's move on. Alright, so in the previous lecture we saw the old syntax of methods. In this lecture we are going to see class methods. So now in this syntax we'll pass CLR as an argument. In this argument, CLR represents our class name. Now put colon here, and we'll take a string as our second argument, then hit enter. So now here import regular expressions like this, import RE. So the reason for this is because we want to take some specific values from our string. So we have to use regular expressions because this helps us get values from a string in an easy way. So on the next line, write item is equal to re.findAll. So now I'll give a statement from which I want to get my values. So to get the values, you have to see after which keyword our values are placed. If I write a statement like this, so my laptop is M6600 and the price is 60,000. So here we'll write is word and then is backslash W, the asterisk, and then string. So it will get two values. One is this and the other one is this one. So now on to the next line. Write name is equal to item brackets 0. So for the first value, because its index is 0, so it refers to this word. Now on to the next line. Write price is equal to brackets 1. It will get us the price from our sentence. So index 0 represents the name of our laptop and index 1 represents the price of our laptop. So what do we want to exclude from this statement? We want to exclude is and the space after is. So that it would be at 3 characters. Okay, so I'll write 3 here. Now on to the next line. So let's return our strings. Now this is the crucial part of our program. So here we'll return the CLR and in the parentheses we'll pass the values which we want. Okay, so now we'll use this, run all the code by hitting Shift plus enter. Now how to get the values? So here we don't use an old method like this. M4800 is equal to laptop M4800 50,000 because now we don't have our values in the key values pair. Instead we have a sentence from which we want to get our values. So to print the values I'll use the class name and this class method. So when I write laptop name price, it will call our constructor, but we don't want this now, so we want to call this method now. So to do this I'll write laptop.from underscore string my laptop name is M4800 and the price is 60,000. Now hit shift plus enter. So now this is an object defined. If I print it like this, then you will see that it's an object. So if we write M4800.dict and we hit shift plus enter, as you can see, this is built as an object. So now one more thing, I'll access this and also the applied discount part. So if I want to give a discount of 5%, I'll do that like this. M4800.discount is equal to 5. Press shift plus enter. And let's see if by writing M4800.dict it was inserted or not. So you can see that it was inserted. Okay, so if we want to apply our method of applied discount like this, so M4800.apply discount, then to do this we first have to change here this. So here we use int like this, so return CLR name int price and we run all the cells. So as you can see, it shows the result of our discounted price. We use it because this takes it as a string. Therefore, we need to tell the program that we require an integer here, not a string. So you can see that its original price is 60,000 and after a discount its price is like 57,000. Okay, so originally it was like 60,000 and now it's like 57,000 after the discount. Okay, so now let's conclude what we studied so far. So we talked about class, and so this is our class, and this is our class variable, and these are class attributes, and this is a class method, and these are our instance methods. Now I think it's easy for you to understand like all the things that we covered in the previous lectures. Alright, so we explored different topics. We dived deeper into our class, and then the class variables and class attributes and class method, which is used for building constructors if you want our own. And we also have like instance method, which is a function that we will make in our class. Alright, so for now that's pretty much it. So let's move on. Alright, so in this lecture, the topic that we'll cover is static method. So this method is also rarely used in classes like the previous one, but to reduce the waste of memory and to work professionally, we use this static method. So it's also used to provide logical sense and to improve the readability of our code. Let's see this practically by implementing a static method in our program. So first we have to make a class with the name of student, class student, and after that let's call the constructor define init self name age as we did before. So on the next line write self.name is equal to name and press enter. Now write self.age is equal to age, press shift plus enter, and now make our object so s1 is equal to student Sohail24, then press shift plus enter. Let's check our object by writing s1.dict, then by pressing shift plus enter. In the last lecture we used the class method, but in this lecture we'll use the static method. So the syntax of the static method is the same as the one that we used in the class method, but here we use the static method instead of the class method. So it's gonna be add static method and then enter. On the next line we'll make a method for this by writing define print statement, then by pressing enter. On the next line now print our method, so print, this is a static method. Now run all the code by pressing shift plus enter, and in the next cell let's print the statement of our static method, so s1.print statement, press shift plus enter, and here you go, it works perfectly. So it shows us the result of our static method. So now we've seen how to use it, but let's now explore where to use it and why to use it. So what's the difference between this method and the other methods? So we're going to see this in our next lecture. Alright, but one thing that we need also to cover in this lecture is like why we are not passing any argument in the parameters of the static methods. So as you can see, we have to pass the parameters in our default constructor def init, in our class method, and also in our instances. If I do not pass any parameter in them, then the code will not work. So why is that? Not the same for static methods. What's the reason behind it? So the reason is that our function is part of our class, but it has no link with any other constructor, attribute, or other functions of our class. This means that if we directly know the purpose of our function, that it prints out this statement, then we don't have to use any parameters here. So if I pass the same values of this init method, then it will also consume the same amount of memory as our init method consumes. So this is a waste of our memory because we don't want to use it. So why would you write it here? It's useless for us because we already know that we'll make this function for printing purposes. Then why should we use any attributes or class variables here? So if we don't want to use any self or CRL methods parameters, we can build a static method so it consumes less memory. So if you want to give any arguments in this method, we can give it. But by default, it doesn't require any argument. Okay, so hope it's clear for you now. That's why we use the static method basically. So in this lecture, we've learned about it, like what is a static method, how it's used. Now, regarding the next lecture, we'll do an exercise in which we'll practice all the methods that we've studied so far. So the class method, the instance method, and the static method. And we'll differentiate them for our better understanding of how all of this works. So, yeah, like we'll try to dive deeper in the next lecture so that everything is super clear to you. But for now, that's pretty much it. So, see you in the next lecture. Let's move on. Alright, so in this lecture, we'll do an exercise on the static methods and the other two methods. So I divided this exercise into 3 parts so that you can understand it easily. As we discussed in the last lecture, we'll use all the 3 types of methods which we've studied so far so that you can understand everything. Okay, and yeah, like basically we need to understand like the difference between them. That's why we'll do this. So let's create a class with the name date. In that class, we'll accept three values in our parameters, which would be year, month, and day. And after that, we'll create a method which will be our instance method. In that method, we'll arrange our numeric values into a date format, and after that, we'll create a class method. If our values are in the numeric format, then that's not an issue. But what if we have to get the values from a string? Like if a user enters a string and we have to fetch the date from that string, that's why we have to use the class method. So it helps us to arrange the user's entered data into date format. So we'll also use a static method here. Why should we use a static method? We use a static method here because the date format would be like this: year, month, day, but we don't want our date to be like that. So we want our date to be arranged by day, month, year, not year, month, day. So we want it to be arranged by day, month, year. So to do that, we'll use a static method here. In short, we create a static method that arranges the date format according to the days, like like day wise. So first, let's recap all the methods and see how we can create them, and then we'll see the difference between them. Okay, so that you can understand better. Like if we see the difference, you will better grasp how they work, because it may create some confusion among students about like where to use the class method, the static method, and the instant method. So that's why it's important to differentiate them and to see like how each one of them work in their different contexts. So this exercise helps you to clear all these confusions and you'll understand the use of each method. Okay, so now let's create a constructor by writing def init self year, month, day, and hit enter. After that, in the next line, write self.year is equal to year and hit enter. On the next line, write self.month is equal to month and hit enter. Next, write self.day is equal to day and run the cell by pressing shift plus enter. Now let's create the first object with the name date1 by writing date1 is equal to date 2022-6-17. Run this cell by pressing shift plus enter. So let's check the attributes of the object through date1.dict and then hit shift plus enter to run the cell. Alright, so it shows all the attributes which we've entered. Okay, so these are the numerical values, but if you want to give a format like day, month, year, so to do that you have to create an instance method, and I'm also adding comments in our code so that you can easily understand like what we're doing by reading them. Okay, so this is our constructor. We also call it the init method. So now we are going to create an instance method. How could we determine like which method is an instance method and which one is not? So we'll also cover that later in this exercise. Let's write def arrange value into date self and hit enter. Then on the next line write date is equal to. So we'll arrange the date by concatenating these self variables in a day wise manner. So at first we put our day, then month and year like this. So date is equal to self.day plus plus self.month plus self.year, and also so insert this, so the dash in between day, month, year. Okay, so here we are concatenating the string with integers, so we have to convert our integers into strings, otherwise it will give us an error. So convert them by using str on all the integers. Now press enter and return your date by writing return date. Now check if it works. So first of all, run all of the cells, and in the next cell write date.arrange underscore value underscore into underscore date brackets. So when you hit shift plus enter, you can see that this is arranged in the string format above. We have our numerical values, but they are arranged in a date format. So here we also add a pattern because it shows the meaning of our methods. Now run all the code again. So yeah, it's working. Now this is what we call our instance method. So how could we know that this is our instance method? So the answer is that it passes only self in its parameters. So, and what will the self do here? Like, it's used to call our object name here, 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 and here. So everywhere, like where we use self, it calls our object name. So the self is used as a convention name. Okay, so as I told you earlier, you can write any other name instead of self, but in a professional way, in a professional setting, we write self. And that's what we did here. So to conclude what we just did, like in this lecture, we learned about the instance method, like why we should use the instance method, and how to identify which method is our instance method. So in the next lecture, we'll continue this exercise by creating our two other methods. Alright, so that's pretty much it for now, and now on to the next lecture. Hello and welcome to this new lecture in which we are going to do an exercise on a static method. So basically in this lecture we're gonna create another method. So why are we creating this method? Let's suppose we don't have our date in numerical values like this, but we instead have a string. Okay, so let me give you an example of what I'm trying to say. I'm creating an object with the name date2, which is equal to a string like this. So date2 is equal to date, brackets, today. Today's date like is 17/06/2022. So we have here a sentence which describes today's date. So how can we fetch the date from this sentence? That's why we are creating this method. So this method helps us fetch data from a string and converts it into an object, as you have done earlier. So we are using the class method here by writing class method. So it's add class method. Now hit enter. On the next line write def get data from string brackets CLR string. So we take two parameters. The first is CLR and the second is string. So we took a string here because this object also contains a string. You can write another name other than string, but you have to give a meaningful name. So we'll use a string here. Now press shift plus enter. And on the next line import a regular expression like this. So import RE. If you want to get the data from a string, we have to use a regular expression. If we have multiple lines of string, we can also fetch data from that via regular expression. Now hit enter, and on the next line write date is equal to re.findAll, where we use the findAll method, and in that we use this pattern, 2 digits, brackets 17, then dash, again 2 digits, 06, then dash, and then 4 digits, so 2022. So I'll write this in the findAll method like this. So date is equal to re.findAll brackets, and then we put like the relevant syntax. You know, like if you have some knowledge about regular expressions, or if you don't, you can like easily Google this function and you'll understand like how it works. So it's not hard actually. We're just like trying to trying to read the text and trying to apply the findAll method. So by doing this, by writing date is equal to re.findAll brackets d and then curly brackets 2 and so on and so forth. So this is where we'll give our values in two formats. So the first one is like this, like 0 0 0 0 and then 0 0 0 0, and then we use a NOR sign, as you can see in front of you, and after that we give our second format like this. So it's like 0 0 /0 0 like 0 0 0 0. Like the first one, remember, it was like 0 0 dash 0 0 dash 0 0 0 0. The second one is like 0 0 /0 0 and then 4 zeros. So we gave these two formats because it should be possible that the user does not use our first format. Like if he doesn't use our first format, then maybe he uses the second format. He may be using like another format to put the dates that he wants. So I've provided these two formats, and I'm also commenting here about like what this line is about. So now write like brackets 0 to add them to the list of items, hit enter, and in the next line write data.replace brackets, okay, / dash. Now what does this do? So the replace method we used here will change the / into dash, and then we use the split method to split this string into words, and we will assign it to the list date, like this. The list underscore date is equal to date dot replace / and then dash dot split, okay, dash. Okay, so here will be our day, then the month, then the year. On the next line, we write date is equal to list underscore date brackets 0. So let's copy this line 2 more times and change it to 1. And on the next line, it would be 2. And it would be a month here and a year here. So now press enter. And on the next line, we'll return our date like this. So return CLR, date, month, year. Now run the cell. So here we have to call our get data from string method with date like this. So date2 is equal to date dot get data from string brackets. Today's date is like 17/06/2022. So we have an error here. Okay, so here I have to write comma string because we are using string here. Now run the cell again. Okay, so we have an error again. Yeah, I got it. So here I mistakenly wrote date. It should be data. Okay, now run all the code again. Let's check if it's working or not. So write date2 and press shift plus enter. Alright, so it's working now perfectly. Let's check our object by writing date2 dot the ICIT and press shift plus enter. It shows year, 17. So let's check this. I think we need to rearrange the day and the year. So now run the code. Okay, so I hope by doing this, like by doing it this way, it will work. Okay, so an error occurred again. So let me check this again. Yeah, I made a mistake here in the constructor. I gave the year in the first place, so I need to do the same in the class method. So first I give year, then month, and then the day. Now run all the cells again by pressing shift plus enter. So yeah, it works now. So here you can use the arrange method, date2 dot arrange underscore value underscore into underscore date underscore pattern, and now run the cell, and it's working as you can see. So it gets our date from a string and it prints it in a date pattern. Okay, I hope you now understand this topic. So that's pretty much it for now, and now on to the next lecture. Alright, so this lecture is a continuation of the previous lecture. So we've covered the class method and the instance method in our previous lectures. So in this lecture, we'll see the static method. So let's start by writing add static method. But before proceeding further, one remaining thing which you have to cover from the previous class is why we call this class method. So this is because, as you can see in its argument, we pass the CLR, and also you know that in the instance method we pass self, which is used to call our object. So the same goes for the class method. In the class method we pass CLR, and it's used to call our class. So it means CLR represents the date here. So like this here, it represents the date. Okay, so now let's get back to the static method. The purpose of using the static method is that if our date format is in the wrong pattern, meaning that it shows like the year dash month dash day instead of day month year, therefore we need to arrange them in the correct order. So that's why we use the static method. Okay, now write def set date pattern. On the next line, one thing to understand here is that the function did not take any parameter from the class method nor from the instance method. So this means that in the static method we don't pass self or CLR. This method is isolated from every other method we used above. That's why it does not take any parameter from our class or methods. And for this reason it consumes less memory. In the static method, we already know what we want from our static method. So a question arises here, like where should we use our static method? We use this method when we already know what we want to do with our method. For example, if I want to print something and I already know what I want to print, then I can use the static method. And because we already know what we want from our method, that's why we don't need to pass any parameter from our class or method here. And you also use this method because it consumes a less amount of memory and it improves the efficiency of our program. So here the next question before us is, Like if we don't pass any parameter from our class or method here, then what should we pass here? So the answer is that we pass what we want from our static method. In our scenario, we want to arrange our string, right? So here we also pass a string in its parameter, like this def set date pattern string. Now in the next line we write list1 is equal to string.replace, okay, open brackets, / and then dash dot split, open brackets, and then here we put the dash. On this line it will replace the / with dash, and then it will split our string. So now press enter, and in the next line write date underscore update is equal to list. So here in list1 we want our last item to change into the first item and vice versa. So this means that you have a current pattern like year, month, date, but you want to change it to day, month, year. Therefore our last item should have to be replaced by our first item. So how could we do that? Here we used a split method, which split our string into 3 parts. So currently we are getting this 2022-06-17, but we want to change it to 17-06-2022. So that's why we use list1 brackets 2, which represents the third item. Well, okay, 2022. So 17 replaces 2022, and 2022 replaces 17, right? Okay, so now here we concatenate it by using date underscore update is equal to list1 brackets 2 plus dash plus list1 brackets 1 plus dash plus list1 brackets 0. So here list1 brackets 1 represents 06 and list1 brackets 0 represents 2022. Now press enter, and on the next line return our list by writing return date underscore update. Now you may be thinking that you have not written str here. That's because we are using list here. And as you know, in a list, all the items are already placed in a str format. Alright, so now here we create an object with the name of date3 like this. So date3 is equal to date.set data pattern, open parenthesis, 2022-06-17, and then run the code. Oops, an error occurred, so let me see. Let's print our list to see if it's working or not by writing print list1. So it's not working. Okay, maybe we should create an object first. So date3 is equal to date 2022-06-17, right? So let's use the method date3.set date pattern 2022-06-17 and hit shift plus enter. So it still doesn't work, and yeah, like I get it now. I made a spelling mistake. It should be list1. Okay, and now run all the code. So okay, you can see that now it's working. So that's our data and that is our output. All right, so we can also use it like this. Date4 is equal to date.set date pattern 2022-06-17. Now run the cell. Okay, so it will set our date pattern in date4. You can see it by typing date4 and by hitting shift plus enter. As you can see, it sets our date pattern like this. So in this lecture, we learned about the constructor method, which is used to construct classes and objects, the instance method, and what is the purpose of self in the instance method, the class method, in which we call our class through the CLR parameter, and the last one is the static method, which is isolated from all other methods, and we use it when we already know what we want from this function. Okay. I hope that by now everything is super clear to you. So when it comes to this lecture, that's pretty much it. Alright, so yeah, that's it for now. We can move on to the next lecture. Alright, so in this lecture of OOP in Python, we'll cover 2 topics which are the most important ones in object-oriented programming. So the names of these 2 topics are abstraction and encapsulation. These topics are not so huge, but when we use object-oriented programming in our code, most of the time we use abstraction and encapsulation. So let's begin with a brief introduction to each one of them. So first we'll talk about encapsulation. To understand that, we are going to create a program that demonstrates an example of encapsulation. Okay, so in this program, we are going to create a class with the name phone, And in that class we'll pass 3 attributes except self, and those attributes will be brand, model name, and price. After that we'll create 2 instance models. So the first one will be make a call. When we give a phone number to that method, it will print calling with the phone number. And in the second instance method, we'll print the full name of the user, and with the help of the self parameter, we'll access the brand and model name of the phone and try to print them through concatenation. So let's do it practically by making a class like this. So class phone, hit enter. On this line, call your constructor by writing def init self brand model name price. Now hit enter, and on the next line assign parameters to variables. Self.brand is equal to brand, hit enter. On this line write self.model underscore name is equal to model underscore name and hit enter. On the next line write self.price is equal to price, and now press shift plus enter. Now create an object with the name of phone1 like this. So phone1 is equal to phone Nokia 1100 4000, and now run the cell. So let's see if our object was created or not by writing phone1.dict and hitting shift plus enter. So yeah, it works. Okay, so now we are going to create our instance methods. So the first one is when we give a phone number, then this method makes a call on that phone number. So write def make a call, parenthesis self phone number. Now hit enter, then print f quotation marks calling curly brackets phone number, okay, or phone underscore num, close the curly brackets, quotation marks, close the parentheses, quotation marks, and hit enter. On this line we use f, which represents the format specifier here. So on the next line we'll create our second method, def full name self, and hit enter. On the next line return f self brand self.model underscore name. Okay, so run all of the cells. Let's check if it's working or not. So for this, let's call our function phone1.make a call. Then we hit shift plus enter, and here we go. It's working. It prints calling with the phone number. So now also add some dots here. Alright, so now it's done. Okay, so now let's see if our other methods work or not. In the next cell, write phone1.full underscore name and hit shift plus enter. Okay, so it throws an error. Let me see what the problem is. Okay, so here I made a spelling mistake. Here it should be model. Now run the code again. Yeah, it's working now. Okay, so there is one more thing we have to do with our make a call method. As you can see here, we're passing self in the parameter of the make a call method, which has no use in the method itself. So this is a nice example of a static method. We use self in the full name method because this method calls self.brand and self.model name in the return statement. But in the make a call method, we are not calling any self attributes. So this is wasting our memory. That's why here we remove self. Okay, therefore, here, we make this method into a static method, which minimizes memory consumption. So run the whole code to see if it's working or not. Okay, now it's working perfectly. Alright, so now here we look at our encapsulation topic. What is encapsulation? So encapsulation is those methods or attributes which are linked with each other. Like here, phone is linked with brand, model name is also linked to it, price of the phone is also linked to it, make a call method is also linked to it, and so is the full name. So this means that these attributes or methods which are linked with their class must be placed under its linked class. So this concept is called encapsulation. Okay, so to understand it in detail, we'll take an example from our previous exercise on static method. Okay, so copy this code and paste it here. So here, what we need to understand is that this phone class has all the attributes and methods which relate to it. So that means that if I want anything which is related to our phone class, it should be placed within that class. If any attribute or method is not in that class, that means that we haven't created it yet. Likewise, here we have a date class, and all the attributes and methods which are present in that class are related to it, and that is what we call encapsulation. So let me repeat this one more time. Encapsulation is a concept in which we place all the attributes, objects, and methods within a class with which they are related. So if we place related attributes of the class outside of that class, then this will cause problems in our code, and it is also a professional way of coding. So if you are placing all the attributes within its relative class, then this shows the professional coding behavior. Now let's understand abstraction. So let's consider a scenario where we hired two developers and gave them a different task. Developer 1 is working on method 1, and developer 2 is working on method 2. And we don't want to see the code of each other, we don't want them to see the codes of each other. But developer 1 needs to use the developer 2's method. So not only see it, but he wants to use the method. So how would it be possible that without showing the code, how can the developer 1 use developer 2's method? So this will be possible in object-oriented programming through abstraction. So we use abstraction to hide the functionality of our code from others. Now developers don't need to know how it actually works. They can use it through its class name or a method name. So we use abstraction on a daily basis. If you want to download anything from a website, we can download it by using the download button. Developers don't put any code or anything else for this downloading procedure. And developers hide all the back-end processes from us by using abstraction. So to hide the complexity of a code and make it easy to use for users is what we call abstraction. So one more daily basis example uses mouse, keyboard, laptop, and mobile phones. We don't need to know the back-end procedure of how they work and what is the coding behind them. We absolutely don't need to know what the coding behind all these elements like the mouse, keyboard, laptop, and mobile phones is to be able to use them. We can simply just use them. So this is the concept of abstraction, where we don't know the actual code or procedure, we only use them. Okay, so hope you understood the concept of abstraction and encapsulation. And yeah, basically, so in the examples that we worked on, we used the concepts of encapsulation or abstraction. So this is not coding or anything like that. This is just a concept or a technique which you have to follow in object-oriented programming. Alright, so that's pretty much it for this lecture. And now on to the next one. Alright, hello and welcome to this new lecture on OOP in Python. So, in this lecture we'll learn about the most important topic of object-oriented programming, which is inheritance. So in this lecture we'll see what inheritance is and how we can use it. So we are using the same phone class which we created in our last lecture. Okay, so I'll give a quick overview of this code in case you forgot that, and then we'll proceed further with our inheritance topic. So we created a class with the name phone, and on the next line we created our constructor and passed 3 parameters in it with the name brand, model name, and price. Then we created its attributes. After that we created 2 methods. The first one is the static method and the second one is the instance method. Okay, so this is the overview of the code. Now let's begin with our topic. So to do that we have to create one more class named smartphone. So let's copy this and paste it into the next cell. In smartphone class there will be also a brand, model name, and a price, but we'll add some more attributes to make it different from the class above. So let's add RAM, internal memory, and rear camera in it. Now also assign its attribute to a variable like this. So self.ram is equal to RAM, hit enter, and on the next line write self.internal memory is equal to internal memory and hit enter. At the end we have self.rear underscore camera is equal to rear underscore camera. Now we have made our 3 attributes for RAM, the internal memory, and the rear camera. The method that we'll use is the same as the one we used in the above class. So make a call method for printing by writing calling plus phone number and full name method for returning the brand and model name of phone. Now you may notice that some lines of code are repeated here. So we have attributes and methods in our phone class, and we are using the same methods and attributes in our smartphone class. This causes redundancy in our program and will also consume more memory. So this is where inheritance helps us. With the help of inheritance, we can inherit some properties, attributes, and some methods in our class from another class. So there are two ways of doing this, by the common method or an uncommon method. So programmers use both as per their needs. I'll explain both methods to you. After that, you have to decide which method suits you. So if you want to inherit a class within another class, in this case, we want to inherit our phone class into our smartphone class. So we'll write the class name here in the parentheses of the smartphone class like this. So class smartphone phone. Now, in the smartphone class, we have a repetition of these three lines of code. As you can see, they are already written in our phone class, so we can remove them because we inherited the features of our phone class into smartphone class. Now on this line, you have to write phone.init parenthesis self brand model name price close the parenthesis. So in this method, we've passed the same attributes as the ones we passed in the above class, so as to inherit these attributes in our smartphone class. Now these attributes are inherited in our smartphone class, and as we passed phone in our smartphone class, then all of these methods are already inherited in our smartphone class. Now let's check if this works or not. So okay, for this we'll have to create an object of our phone class and print its price attribute. After that we'll call the instance method of our phone class, and then we'll do the same for our smartphone class. Here we also have to remove our methods from our smartphone class. As you know, we inherited all the methods from our phone class, therefore we don't need them and we don't have any repetition of work. So these attributes are not present in our smartphone class, but through inheritance we'll use them in our smartphone class. On the next line, create an object with the name of phone1 like this. So phone1 is equal to phone Nokia 1100 4000, then hit shift plus enter, and on the next line write phone1.price and hit shift plus enter. It prints the price. Now let's call the instance method of our phone class by writing phone.fullName and by hitting shift plus enter. As you can see, it shows the full name and model name of the phone. So now let's do the same for our smartphone class. As you can see, this instance method is not defined in our smartphone class, but it will work because we inherited this method in our class. So let's do it practically. In the next cell, create a class by writing smartphone1 is equal to smartphone, open parenthesis, Samsung A7 60,000 4 gigabytes, 128 gigabytes, and then 25 megapixels. So I'll call the price attribute, which you can see above in the smartphone class. We haven't specified our price attribute, we inherited it from our phone class. So let's call the price attribute in this cell and then press shift plus enter. You can see here that it's working and it prints our price. Now let's check if our full name method works or not without any declaration in our smartphone class. So to do that, write smartphone1.full underscore name and press shift plus enter. As you can see, it prints our brand name with the model name. So this is the purpose of inheritance. It reduces the repetition in our code, and it also is a professional way of writing code. So it's a professional way of writing code, and it reduces the redundancy of our code. So if two classes have the same attributes, then we don't need to write them for both classes. We can write the code for one class and inherit it in another class. So as I said earlier, there are two ways of doing this. One is the common way, and the second one is an uncommon way of doing this. So we've seen the uncommon way. Now let's see the common way of doing this. Let's comment it down here. So this is our uncommon way of doing inheritance. And one more thing you have to know here is which class is our parent class and which one is our child class. So our parent class is that class from which we are using our attributes. In this case, the phone class is our parent class because we are using parameters from it to our smartphone class. So we can also call this base class or parent class. And for smartphone class, we can call this our derived class or child class because it inherits the phone class in it. So now let's see here the common way of doing inheritance that's used by most developers. So first of all, comment this line and we write super keyword and then call the init like this. So super parenthesis dot underscore init. So here we don't need to pass any self keyword in the init because super does all the work for us. Okay, sorry, so here we don't need to comment that line. We have to comment this one. Yeah, like we still have to comment this one instead. Yeah, actually we have to comment a line, but not the previous one. It will be this one. Now here we copy our brand, model name and price and paste it here. So we paste them here. And by using the super keyword, we don't need to write the self keyword or anything else here. So this is the common way of doing inheritance, and also it's a method used by most developers. So now run all the code here and see if it works or not. Okay, so an error occurs here, so let me see that. Okay, we have to add underscore underscore after the init. Okay, now run it again, and as you can see here, it's working perfectly. So this is our uncommon way, and this is our common way of doing inheritance. Okay, so that's it for now. I hope that everything is super clear to you. But when it comes to this lecture, that's pretty much it. So let's move on. Hello and welcome to this new lecture on OOP in Python. In this lecture, you'll learn about multi-level inheritance, which is one of the main concepts of object-oriented programming. In the last lecture, you learned about inheritance and how we can use inheritance in the Python language, and you also saw the benefits of inheritance, how it helps us remove redundancy and prevent memory consumption. So in this lecture, we'll try to understand with the help of a base or a parent class, like can we create more than one child class? And that's what we'll see. And the answer is yes, we can. So let's do it practically and see how we can create more than one child class through our base class. So let's do a recap of our last lecture. So we'll recap our last lecture. And as you can see, like this is our phone base parent class, which we created in our last lecture. And in it, we called the constructor and created 3 attributes. So we then created a static method and an instance method in it. And here we created our smartphone child class and inherited the 3 attributes, brand, model name, and price from the phone class with the use of the super keyword. And we also inherit or make a call static method and our full name instance method in the smartphone class. So we can use them in our smartphone child class in the same way we are using them in our phone class parent class. So this is the review of the last lecture. Okay, we'll first talk about how we can create more than one child class from our base class. Okay, so copy this line of code and paste it in the next cell. Change smartphone into smartphone 2 and run this cell. Let's make an object here for the smartphone 2 class like this. So smartphone 2 is equal to smartphone 2 Samsung A7 60000 4GB 128GB 25 megapixels. Then press shift plus enter. Now that you've created our object, let's see whether it's working or not by writing smartphone2.fullname and run the cell now. Okay, oops, so an error occurs. Sorry, I forgot the underscore here. So let's run it again. And yeah, now it's working perfectly. And you can see that here we can create more than one child from our parent class. So now let's dive into a multi-level inheritance for better understanding. So let's make another class with the name of flagship. To do this, copy the smartphone class code and paste it into the next cell. Now make some changes in the class. Okay, so first change the class name into flagship and then in the parentheses change phone into smartphone. Because in this class we are inheriting attributes from the smartphone class. Okay, then add one more parameter, front camera, in the constructor. So you can add more things to it, but we are creating these classes just for our understanding, like for understanding purposes, for clarity purposes. So for that, it's enough. Okay, sorry. So front camera should instead be added here in the flagship class. Also shift this flagship class cell above the smartphone 2 class. Now phone is our base or parent class, and smartphone is its child class, and then flagship is the child class of smartphone. So here it should be smartphone, not smart. Okay, so let's comment on this code for now. And as you can see, in smartphone we have self.tram, and in the phone class you also have self.tram. So the same goes for internal underscore memory and rear underscore camera. Okay, let's assign the front camera attribute to a variable here in the flagship class like this. So self.front camera is equal to front underscore camera. So now one question may occur in your mind, like why are these three attributes placed in the smartphone and flagship class too? So this is a repetition of code. So yeah, that's why we remove these attributes from here, and also remove this super keyword code and the comments in the flagship class. Now let's call smartphone here by using the super keyword like this, so super.init. So here let's call all of the attributes which you want from a smartphone. So copy this and paste it here. Okay, so super.init price RAM internal memory rear camera. We don't pass self here because we are using the super keyword, and this is a common way which is used by the majority of developers. So the front camera is the new attribute in this class, so it remains as it is. Now as you can see here, we don't have RAM internal memory and rear underscore camera attributes in the parameter of our flagship class, so we access them from our smartphone class. Likewise, we don't have these attributes in our flagship class, and it also is not present in the smartphone class. But as you can see here, smartphone class inherits these attributes from the phone class, so it means that smartphone has these attributes for that reason. So flagship class can also inherit these attributes from smartphone. So this procedure or concept is known as multi-level inheritance. In short, you can see that these attributes like brand, model name, and price are not placed in smartphone class, but they are coming from the phone class to the smartphone class due to inheritance. Okay, so at first, these attributes are not placed in the smartphone class, but after the inheritance smartphone class, we also have these attributes. And we are inheriting the smartphone class into the flagship class. It means that it also has the attributes of the phone class. So flagship class inherits smartphone class, and smartphone class inherits the phone class. So flagship class has both the attributes of smartphone class and the phone class. So as you see here, brand, model name, and price was inherited from the phone class into the smartphone class, and then brand, model name, and price plus the attributes of the smartphone class, which are RAM, internal memory, and rear camera, was inherited from smartphone class into the flagship class. Now here, we don't need to write phone in the parentheses of the flagship class because the smartphone class is already inheriting them from the phone class. So we need to call only smartphone class here, and this is a multi-level inheritance. So let's make a flagship object and see if it's working or not. So in the new cell, write this, 1 plus is equal to flagship. Now copy and paste these parameters and also add front camera here like this. So 1 plus is equal to flagship Samsung A7 6000, 4 gigabytes, 128 gigabytes, 25 megapixels, 12 megapixels. Now run the cell. Okay, so an error occurs. I think we didn't run this cell, so run the cell again. And yeah, it's working now. So you can see that in the flagship class, we don't have a full name method. It's inheriting it from the smartphone class. And in the smartphone class, we also don't have a full name method. But the smartphone class inherited its method from the phone class. So in short, our flagship class is inheriting this method from our phone class. Okay, so let's check this by calling the full name method with our flagship class object. So for doing this, we have to write 1 plus dot full underscore name parentheses and then hit shift plus enter. So as you can see, it prints the full name by using the full name method, which is present in the phone class. I hope you learned a lot from this lecture. Like in this lecture, we covered what multi-level inheritance is, and we saw how we can make a child class from another child class. And we also saw that the second level of a child class can inherit its parent attributes as well as the parent of its parent attributes, meaning its grandparent attributes. Alright, so that's pretty much it for this lecture, and now on to the next one. Alright, so in this lecture, we're gonna cover the topic of multiple inheritance in object-oriented programming. In the previous lectures, we covered inheritance and multi-level inheritance. We also covered the two methods, method resolution order, method overriding, which are used to understand the complexity of inheritance. And after that, we also covered the isInstance method, which is used to determine whether a particular object is an instance of this specific class. And the second method we saw is subclass, which is used to check whether the particular class is the subclass of this specific class. So there are the topics related to the inheritance that we covered so far. We are going to learn about multiple inheritance, and we'll go through method resolution order so that you can understand it better. In this lecture, you'll also see how MRO can be beneficial to us. So now, let's make a class with the name A, like this. So class A, colon. Now, I don't want to create any attributes. That's why I'm not calling the init method here. So now I'll directly create an instance method with the name of class A method, like this. So define class A method self. Now press enter, and on the next line return I'm just a class A method, then hit enter. Now make another instance method with the name of hello. So def hello self, then hit enter, and on the next line return hello from class A. Now run the cell. Now in the next cell I want to create an object with the name of instance A, like this. So instance A is equal to A parenthesis. We don't pass any argument here because we haven't created any attribute in the above cell. So now run this cell. Now in the next cell I call class A method like this. So instance A dot class A method. Then I hit shift plus enter. It shows the result of our method. Now proceed further and make a second class with the name B. So here copy the code from the class above and paste it here. Then change the class name to B. Let's change it to B here and here also. Now run this code. If I create one more instance like this, so instance B is equal to B parenthesis, then hit shift plus enter, and in the next cell call this method like this, instance B dot class A method, and then run the cell. So it's showing the correct result. Now let's use multiple inheritance here for that. So create a class with the name C, like this, class CAB. In this class I've inherited two classes, A and B. Now on the next line, I'll not create any method. I'll only write pass, which means run only this class, don't do anything else. So now run this cell, and now I'm creating an instance of C, like this. So instance C is equal to C parenthesis, and then run this cell. Now I'll call the class A method here, and one question arises. So it would be class B method self and not class A method self. Now run it again. Here also change class A method self into class B method self and run all of the cells. Now I want to call class A method like this, instance C dot class A method self, hit shift plus enter, and as you can see here it prints the text in the class A method. So I'll call the class B method here, copy this code and paste it to the next cell, and change the B into A so that it prints the correct text. Now I'm going to use the hello method. So as you can see here, the hello method in class A and the hello method in class B have the same name. So what should it print when I call the hello method? Here I've changed the name, but the hello method has the same name on both classes. So what should it print? Like class A's method or class B's method? What should it print? Okay, let's check this. So in the next cell write instance C hello. Now your class B method will run, but it will run the class A's method. Okay, run this cell. As I told you, it runs the class A method. So why would it run the class A's method? To understand that, we have to take the help of method resolution order. So how can we use that? You already saw it in the previous lectures. As you know here, like we write help instance C and then run this cell. So this is our method resolution order here in the list. You can see that at first it executes class C. If it didn't find a method in it, then it goes to class A. And after that it searches for the method in class B. So the first is C, then A, and then B. Therefore it prints the class A hello method because our program finds the method in it. So it doesn't go further for the search. So let's suppose if this hello method was placed in class C, then it will print that from class C according to method resolution order. So let's check this by copying the hello method code from here and by placing it in class C and by changing A into C here. Okay, so now run all of the cells and you can see that it prints the hello method from class C because at first it checks in the C class and it finds that the method in C, so that's why it doesn't go to class A and class B. Okay, so if you comment this out and then it will go to class A, and you can see that, right? Okay, so what if you want to change their order from class A to class B? So to do that, you can reverse this order. So from the parameters like this, class C, parenthesis, B, A, it will change the resolution order. So let's check this and run the code here. As you can see now, after C it prints B because we have changed the order from here. So it runs from the left to the right. Like at first it executes C, then B, and then A. Now you have understood what multiple inheritance is. If I want to access class B and class A in class C, I can do it easily with the help of multiple inheritance. Okay, one more thing to point out here is that multiple inheritance is used by fewer developers because it complexifies your code. So it would make your code more difficult to read. That's why it's used by fewer developers. Because if you need to understand or search anything within your code, then it would be very difficult for you. So it's all up to you if you want to use it in any situation where it would be necessary to use this. So you can use this. Okay, now we are going to see if there is any other method for using multiple resolution orders. So let's see how we can do that. So for that, you have to write instance C. Like here we have to write c.mro. Now press shift plus enter. And as you can see here, it prints the order. So this is a method of MRO. Okay, and with the help of this, you can find the order. And as you know, at first Python executes C, then B, then A. With this method, you have fewer details as compared to the help method. So it would be more beneficial to use the help method. So it's all up to you, like which method you prefer. We have one more method to find the order according to MRO. So for this, we have to write like c.__MRO. Now run this, and you can see that it prints the result in a round bracket with the same order, like C, B, then A. But these methods are not much readable, so the most efficient way of doing this is with the help method. And yeah, I hope that everything is clear to you by now. So that's pretty much it for this lecture, and now on to the next one. Alright, so in this lecture we'll study two object-oriented programming methods. The first method is MRO, and the second one is method overriding. MRO stands for Method Resolution Order. These methods are used to reduce the complexity of inheritance. We are using the last lecture's code to understand these two methods. So as we discussed earlier, this is the phone class we created in our last lecture, and then we called the attributes and methods in it. So we have a make a call method and a full name method. So a method is also known as a function. The difference between method and function is that if we call a method or function outside of the class, then we call it a function. And if we call it within the class, then we call it a method. Okay, so we used an instance and a static method, which we discussed earlier. After that, we inherited our phone class into our smartphone class. Then we used the super keyword to access the attributes of the phone class. When we pass the phone class as a parameter into our smartphone class, it defaults and inherits all the methods from our phone class into the smartphone class. So here we inherit our smartphone class into the flagship class. We then inherited brand, model name, price, RAM, internal memory, and rear camera from our smartphone class. And we also added a new attribute of front camera here. So now, how does it work? At first, when you want to print brand or model name, it will go to the flagship class and see that it was inherited from our smartphone class. Then it goes there and checks whether it has these attributes or not. So if it doesn't have these attributes, then it checks from the phone class, and when these attributes are found in the phone class, it will print the result. Okay, so now we'll create an object for every class with the help of that. We'll understand the concept of MRO and method overriding. So let's create a phone1 object in this cell like this. So phone1 is equal to phone Nokia 1600 4000. Then press shift plus enter. Then in the next cell, we are going to create an object for the smartphone class like this. So smartphone 1 is equal to smartphone Samsung A7 60,000, 4 gigabytes, 32 gigabytes, 25 megapixels, and then press Shift plus Enter. So now in the next cell, let's create one more object with the name of 1 plus like this. So 1 plus is equal to flagship parenthesis 1 plus A2 60,000, 4 gigabytes, 32 gigabytes, 25 megapixels, 12 megapixels. Now run these cells. So here we made our 3 objects. Let's check them by applying the full name method to every object like this. So phone1 dot full name, hit Shift plus Enter. You can see that it's working. Now check it through the smartphone 1 object. So yeah, it's working correctly. And do the same for 1 plus. So it's also working. Now let's understand like what MRO is. So if I want to check in the flagship class or in any other class in which order Python runs our method. So for studying the demand of our array, you need to write help, and in the parentheses you need to write the class's name or the object name of that class, like help parenthesis 1 plus, then you run the cell. Now you can see the details of our flagship class, and here you can also see the method resolution order of the objects used in that class. So you can also see other details related to the flagship class, but for now we focus on the method resolution order. So now what does it tell us here? Here it tells us that if you want to call or find any object, method or function from any class, in what order does Python search that object, method or function? So here Python will first look in the flagship class, then it looks into the smartphone class, and after that it checks in the phone class, and at the end it will check the built-in objects of Python libraries. So the same thing it does with the full underscore name method above. So first it goes to the flagship class and searches if it has like the full name method or not. It did not find it here, then it goes to the smartphone class and checks it there. So it did not find it here, then it goes to smartphone class and checks it here, but it didn't find it. Then at the end it goes to our phone class and finds the full underscore name method there. Then it executes the code of the full name method and prints the full name of the mobile phone. So if we check the MRO of the smartphone class, then it will show us the order according to that. Like here you can see, first it will check the smartphone class, then it will go to the phone class, and as you can see it doesn't include the flagship class. So why doesn't it include that class? Because our smartphone class is not inheriting the flagship class, but it is the flagship class that is inheriting the smartphone class. So a class inherits properties of other categories in the MRO because it has all the features of that class. So that's the reason behind it. Here you can see that it doesn't have a full name method. Also, it's not found here, but it is in the phone class. So that's the concept of method resolution order. Now let's see what is method overriding. So if we call this full name method, it will check if it is here, then here, and it prints the result. But what if I want to add some extra information here to create a new function or method? So let's copy this from there and paste it here. So now I want to print the price of the smartphone, so I can add it here like this, return F. Okay, so quotation marks, self-brand, self-model name, and price is self.price. And then run the code, and in this cell print smartphone1.fullname and run the cell. Now you can see that it prints all the information here. So it found the method in the smartphone class, then it didn't go further and printed that. Okay, so I then commented out this full name method code. So let's see what will happen. Now I run the code and you can see what it prints. It only prints the brand and model names. So the reason for this is that at first our program checked the full name method in the smartphone class, but it couldn't find it. It then went to the phone class and found it there. So it printed out our brand and model names. Let's suppose that the function was present in our flagship class like this. But before that, let's see what our flagship class object prints now. So you can see that it prints brand and model names directly. I hope you understand now. Okay, so first it will check it within the class, and then it will check it here and here as well. But if it found it from the flagship class, then it will not go that further. To see this, let's uncomment these lines of code and run the code. Okay, so it shows the result. It found the full name method here, so it doesn't go to the phone class, it stops here. Now you surely ask yourself, like, why wouldn't you choose the full name method of the phone class? Because in the method resolution order, the ordering starts from the last class to the first, so it goes from flagship, then smartphone, and then phone class. Now, if I uncomment the full name code placed within the flagship class and add some extra code to differentiate it from others, we should add RAM information here like this. So return F, quotation marks, self brand, self model name, and price is self price, and RAM is self RAM. And now run all of the code. So here you can see that it prints RAM is 4 gigabytes, which means that it runs our flagship's full name method and not the smartphone's full name method. So because it found the full name method here in the flagship, then it didn't proceed further to do the search. You can see that this function is different, this function is different too, and this one is different as well. So due to the concept of MRO, it will pick this last function as the priority. Because of inheritance, Python sees the classes from the bottom to the top. Alright, so I hope that you learned a lot from this lecture and that the MRO and method overriding concepts are now clear to you. And that you understood in which order our program will run. Alright, so that's pretty much it for this lecture, and now on to the next. Alright, so in this lecture on object-oriented programming in Python, we are going to learn about two methods. The first one is the is instance, and the second one is subclass. So these two methods are related to our inheritance topic, like is instance. So what does instance represent here? It means object. As we discussed in the earlier lectures, method is also called a function. The only difference is that we call it a method when it's placed in our class, and we call it a function when it's placed outside of the class. Likewise, when an object is created via a class, then we call it both an instance or an object. So what's the isInstance method? So this is a method that helps us to find whether a specific object or instance is the instance of a particular class or not. So let's check this by doing it practically. So for this, we have to create one object for the phone class, and one for the smartphone, and one for the flagship class. And after that, we'll see how we can use the isInstance method, and what are the benefits of using that. So let's create the first object with the name of phone1 like this. So phone1 is equal to phone, Nokia 3310 3000, and press shift plus enter. Then create a second object, smartphone1 is equal to smartphone, Samsung A7 60000, 4 gigabytes, 128 gigabytes, 25 megapixels, and press shift plus enter. And then create an object for the flagship class like this. So flagship1 is equal to flagship, Samsung A7 60000, 4 gigabytes, 128 gigabytes, 25 megapixels, 12 megapixels, and then run the cell. Alright, so this is the object of the phone class. This one is for the smartphone class, and this one is for the flagship class object. So we can also give the phone underscore 3310, smartphone A7, and flagship 1 plus names to our objects. Now let's use the isInstance method to check whether the phone 3310 is an instance of phone class or not. So in the next cell, write isInstance, parenthesis, phone 3310, phone, and then hit shift plus enter. As you can see here, it shows true. So we put two things in the parameter of the isInstance method. The first one is the object's name, phone 3310, and the second one is the class name, phone. So it returns the Boolean value, true or false. Let's check our second object by changing the object's name and class's name to isInstance, smartphone A7 smartphone. Now hit shift plus enter. It also shows true, which means that this is an object of the smartphone class. Now check the last one by changing it to isInstance, flagship, underscore 1 plus, comma, flagship. Now run the cell, and yeah, it shows the true value. So we've checked all the objects which are the instance of that class. Now let's check those objects which which are not the instance of that class. So to do this, let's write is instance phone 3310 smartphone, and now run the code. It prints false here, which means that this is not an object of that class. Phone underscore 3310 is the object of the phone class. But now the thing we need to understand, which is related to inheritance, is that the flagship class inherits the smartphone class, and the smartphone class inherits the phone class, which means that when any class inherits the attributes of another class, it means that the particular object or instance is also part of that inherited class. For example, if the smartphone class inherits the phone class, then all the attributes which are placed in smartphone still remain the attributes of the smartphone class, but it will also become the attributes of the phone class. So let's check this by practically implementing it. So here smartphone A7 should also be an object of the phone class. Is instance smartphone A7 phone. Okay, now run the cell. Alright, so it returns true here because the smartphone class inherits the phone class. So all the objects placed in the smartphone class would also be objects of the phone class because of inheritance. Now let's see our third class, or third level class, flagship. So if you create an object for the flagship class, then it is an object of the flagship class, but it's also an object of the smartphone class as well as the phone class. Now check this for flagship class by writing is instance flagship 1 plus flagship and hit shift plus enter so that it prints true. And now check this with the smartphone class. So to do that, we write is instance flagship underscore 1 plus smartphone. It also shows true. It's obvious because flagship inherits the smartphone class, so it's also an object of the smartphone class. Now check this for phone class. So is instance flagship 1 plus phone. Will it be an object of phone class? We already know this is an object of the smartphone class because flagship inherits the smartphone class. Now let's check this by pressing shift plus enter. Okay, so it shows true because as we know, flagship inherits the smartphone class, and in the same way smartphone inherits the phone class. That's why it will also be an object of the phone class. So as you can see here in the flagship class, this brand and model name was not in the smartphone class. These came from the phone class, so in some way flagship class is linked with the phone class. Alright, so we are saying that the objects created in the smartphone class are also the objects of the phone class. But is it true for the phone class that every object which is created in the phone class is also part of the smartphone class? And the answer is no, because the phone class is not inheriting the smartphone class. So smartphone class inherits phone class. Phone class is our parent class, and it's not dependent on any other class. So let's check this practically by writing is instance phone 3310 smartphone. So here we gave the object of the phone class with smartphone class in the parameters, which will check whether it is an object of smartphone class or not. So here it shows the answer is false because the phone class is not inheriting anything from any other class. So let's check it further by changing phone 3310 into smartphone and smartphone into flagship. Now run the code. So here the answer is false because smartphone inherits the phone class's objects and not the flagship class's object. So here the answer should be false, right? Alright, I hope that by now there is no longer any confusion for you when it comes to the is instance method. Okay, so now we'll look at the is subclass method. It's a very simple method. If you want to check about any particular class, like you may ask, is it the subclass of any other class or the child class of any other class? Then you can easily check this by the is subclass method. So let's do it practically by writing is subclass flagship 1 plus smartphone A7. Sorry about that. So here we have to write class names. So it would be flagship and smartphone like this. Is subclass flagship smartphone. It shows true here as a result, which means flagship is a subclass of or a child class of smartphone. So let's check if it is the subclass of phone or not. So for this, change smartphone into phone and then press shift plus enter. It also shows the true result. So now check if phone is a subclass of flagship class, and here the answer is false because the phone class is the parent class. Okay, I hope you understood both the is subclass and the is instance methods. and that this lecture cleared all the doubts about these methods that you had. Alright, so that's pretty much it for now, and now on to the next lecture. Hello and welcome to this new lecture on object-oriented programming in Python. In this lecture, the topic that we'll cover is naming convention. So, likewise, in the last lectures we covered inheritance, multi-level inheritance, and multiple inheritances. So in this lecture we are going to learn about naming conventions. Like, we're gonna see what naming conventions are. So let's dive into the topic. You may learn that in other programming languages there are two kinds of variables. One is the private variable and the other one is the public variable. So I'm writing it here for your understanding. So one is private and the second one is public. But in the Python language, it's a different kind of story. It has every variable in the public mode. So I'm writing it here. You can take it as a note. Okay, so in the Python language, everything is public. Okay, sorry. So here I have to select the markdown option from this drop-down menu. Now here one question arises when we have a large scale project in which we distribute our project to multiple developers. Like, how can we configure private and public variables? Because for developers it helps to define the purpose of variables, and it's easy for other developers to read the code and helps to deal with private and public variables. Because in other programming languages, like, we have the built-in keyword which we can use for private and public. So for that purpose, we have a naming convention in Python, which is written as underscore name with the underscore and the name of the variable. So as you know, in Python, by default, everything is public. So this naming convention helps developers to know that the particular variable with the underscore sign will be dealt with as a private variable. Like, if we have underscore price, then Python developers can easily understand that this variable has to be dealt with as a private variable. So now, this is a convention that is used by all professional developers. The convention is not a rule of Python, it's just a simple practice which is used by all the professional developers to easily read and understand the code of other developers. So if you don't want to use this, it will not have any impact on your program, but if you send your code to any other developer, then it will be hard for them to read your code. So let's understand this by doing it practically. So to do that, you have to build a class phone : Now hit enter, and on the next line call the constructor using this code. So def init self brand model price. On the next line write self.brand is equal to brand. Hit enter and write self.model is equal to model. On the next line write self.price is equal to price. Now run the cell, and in the next cell create an object. Phone1 is equal to phone Nokia 16003000. Now run this cell. Okay, so in the next cell let's print phone1 attributes like this. So phone1.dict, and here shift plus enter. As you can see here, it prints our attributes. So let's use a naming convention now. So here we'll create an attribute of discount like this. Self._discount is equal to 5. Here we used underscore with a discount variable. Okay, so whenever a new developer sees your code, he can easily understand that this variable is used as a private variable. This means that its value will not be changed in the future. So now let's make an instance method here with the name of apply_discount like this. So def apply_discount self : then press enter, and on the next line write discounted is equal to self.price divided by 100 times self._discount. Then write this on the next line. Final price is equal to self price minus discounted. Press enter, and here we will return our final price. So return final price. Now let's run it again and see if it's working perfectly or not. So as you can see here in front of you, it shows the value of the underscore discount price. So it's easy to understand for other developers that this is our private variable. Now let's run the apply discount method. in the next cell like this. So phone1 dot applied underscore discount, press shift plus enter, and as you can see it returns our discounted value. So as we said earlier, this is only a convention which is used by a great number of developers and not a rule for Python or anything like that. So we can also change this into another value. So let's do that. In the next cell, write phone.discount is equal to 2. And here we change the value of the discount variable into 2. So let's check if it's changed or not. So for that, print the dictionary here, phone1 dot, okay, dict, and press shift plus enter. In the next line, you can see that it changed the value of the discount variable. As you can see, its value was 5 and the changed value of the discount is 2. So why did this happen? Because we conceptually deal with it as a private variable. But for Python, it is a public variable. So in Python, everything is public. That's why we use the name convention to tell the other developers that you are using this particular variable as a private variable, so that they should not change its value. If we now use our apply discount method, then it will show a different value as you see here. So it shows 2,940. In short, we are using the name convention as a standard form of coding, so as to show to all the developers in the world that you can read your code and understand it in an easy way. So of course, it's not a restriction from Python. You can change it without any effect on your program. But if you want to stand out in a market with other developers and you want to work alongside other developers, you need to know some conventions which are used by the developers. Except that, you have like one more naming convention, which includes double underscore at the start and at the end of the variable names like this, underscore underscore name, underscore underscore. We have used it earlier above in our init method. So the name of this convention is dunder, and you also call it the magic method. So we'll cover this in our next lecture. For now, let's stick to the syntax of dunder or the magic method. So this is mostly used for creating methods, as you can see above. So the init, like this is also our method, and it will be created as an underscore underscore method name underscore underscore. So that's pretty much it for this lecture. In the next lecture, we'll continue with the naming conventions. Alright, so for now, that's pretty much it. And now on to the next lecture. Alright, so in this lecture we are going to learn about name mangling. In the last lecture, we covered the name convention, in which we studied that the variable which starts with the underscore is used as a private variable, and it's a standard that's made by the developers community. And we also saw that if any developer wants to change the value of that private variable, then he or she can change that, because in the Python language, everything is dealt as a public, which means that it's just a convention or thinking which is used by professional developers so that they can easily read and understand the code of other developers. Alright, so in the previous lecture, we also talked about the dunder or magic method. We have to cover that also, but before we will see the name mangling, and then we'll cover dunder or the magic method. So let's proceed with the name mangling. So what is the name mangling? Name mangling is a feature or process provided by Python which helps you to name your attributes according to their class name. So to understand this, let's take an example. Suppose that you have 3 to 4 classes and you have multiple attributes of each class. Then how can you find a specific attribute of a specific class? So to do this, we have 2 scenarios to solve the problem. The first one is we can write the class name before the variable name, like self.phone underscore brand and self.phone underscore model. And the second method we have is self.underscore underscore price double underscore with the name variable. So it behaves in the same way as we write self.phone brand above. it replaces the class name with an underscore and then a variable name like self.phonebrand. So let's do it practically to understand it better. We are going to print the dictionary of our price variable. So to do that, you have to make an object with the name phone1, like this. Phone1 is equal to phone Nokia 1100 3000. Okay, so our object is created. Let's print its dictionary by writing phone1.dict and press shift plus enter. As you can see here, Python automatically changed our price variable above. So you can see how we wrote that variable with the double underscore, like double underscore price. When we wrote double underscores, Python understood that here we are calling the class's name with the variable name. So it converted that into a single underscore, then the class name, double underscores, and then the variable name. So it's already set in Python. Okay, if anyone writes double underscore with the variable name or attribute name, then Python changes it and writes it as underscore class name underscore variable name. So this is called the name mangling in Python. You know, like in the Python language, that's what we call the name mangling. So now it can be changed into underscore price. If I want to print it like this, phone1 price and press shift plus enter. So here you can see that it generates the error. So phone object has no attribute underscore price. Why? The reason, which you already know, is that it changed it into this underscore phone underscore price. So now if I copy this underscore phone underscore price and print, then it shows me the result. So yeah, it prints 3000. Now you understand the name mangling concept. So let's see where we can use it practically, because it's a very useful concept in the Python language. And with the help of this, you don't have to repeat the class name with a variable name. So just like here, I don't need to write phone underscore brand and phone underscore model. I only have to give a double underscore with the variable name. And it will automatically detect its class and treat it like this. Underscore class name, underscore variable name. So we don't need to do that by ourselves. Let's see an example of this. So here we have copied the code from our multi-level inheritance exercise, and we use this to understand the concept of name mangling. So this is our phone class in which we have created our attributes. Then we created two methods. The first one is static and the second one is an instance method. After that, you have created a smartphone class in which we have created our constructor, and in it we passed our parameters, brand, model name, price, RAM, internal memory, rear camera, and after that, with the name of the super keyword, we inherited our phone class's parameters, brand, model name, price. Then we assigned our parameters to our variables, and then we created an instance method, full underscore name, and we do the same with our flagship class. Okay, at first, comment out these lines of code. Now run this program. So here I have already created a flagship. Okay, so sorry, it's a smartphone object. So we are going to run this, remove this line of code from here and run this code. On the next line, use the full name method with the smartphone2 object, like this. So smartphone2.fullname. It generates errors. So let's run the code again. Okay, so it prints Samsung A7. You already learned in MRO in which order our inheritance works. So let's check our order here by using the help method like this. Help smartphone2. So if you run this code, then here you can see the method resolution order. At first it goes to smartphone, then to phone. So let's comment this line. In fact, remove this line and write flagship1 is equal to flagship. Now copy the above arguments and paste them in this flagship. And add one more argument for the front camera, 12 megapixels. Okay, now run this code. So let's check its dictionary using the flagship1 dot underscore dict underscore forward slash. Okay, so sorry, it generates an error, removing the forward slash from here, and we rerun the cell. That will correct the error that we had. Okay, so it prints the dictionary. Now let's see its MRO. So for that, write help flagship1 and run the cell. So here you can see the order. At first it chose the flagship class, which means that if we want to print anything like this, like if here we print full name of the mobile like this, flagship1.full name, okay, so it prints Samsung A7. So how does this work? First it goes to the flagship class, and if it doesn't find a method there, then it goes to the smartphone class, and if it doesn't find it, then it goes to the phone. So it's found in the phone class, so it prints the result like this. Now one question arises here, like what if I uncomment this code, then what will be printed here? So let's run all of the code again. Here you see that it prints price with the full name. Okay, sorry, so comment out this code because we want to print the flagship1 object. So here you can see that it prints the price with the full name. If you see according to the MRO, then our full name method of the smartphone class will run, because we saw in the list that at first flagship will run, and then smartphone, and then phone. But I don't want that. So instead I want to run the full name method of our phone class. But Python works according to MRO, so it will go to flagship class and then smartphone class. If it finds the full name from here, then it would not proceed further. So how can we achieve that? This is where name mangling will help us. If I use double underscore here like this, so underscore underscore full name underscore name self, and in the smartphone class also full name self, now both methods have different names. Now it's not just a full name self, it also has a class name attached with it. So now run all of the code and see what happens. As you can see here, it throws an error because our program couldn't find the method with the name of full name self. So I now have an option to choose which class method I want to run here. If I want to run the phone class's full name self method, for that I have to write here flagship1.phone full name, then run this cell. So here it prints Samsung A7. If you want to print smartphone class's full name self method, you can remove the underscore from the rest of the method's name. After that, add a single underscore, then the class name smartphone, then double underscore, and finally the method name full name self. Now hit shift plus enter. So here it runs your smartphone class full name self method, and as you can see it prints Samsung A7 and the price is 6,000. So here it breaks the rule of the MRO, because as you know, according to the MRO, it will first go to the flagship class, then the smartphone class, and then the phone class. But what if we want to run the method of a specific class? So to do that, we use the name mangling. It helps to differentiate methods of different classes with the same name. So I hope that you understood the name mangling concept from this lecture. For now, that's pretty much it. In the next lecture, we are going to talk about the dunder topic. So, alright, for now, that's it. And now on to the next lecture. Alright, so in this lecture, we are going to cover the dunder methods, which is also known as the magic method. In the last lecture, we covered the topic of name mangling. So let's try to understand what the dunder method is. Here we have already created our phone class with some attributes. So as you already know, in Python we have a list, which is used to store more than one item. So here we are creating a list. L1 is equal to 1, 2, 3. Now hit shift plus enter. In the next cell, print this list, print 11, and hit shift plus enter. You can see that it prints the list of numbers that we stored in L1. This is our class, 1, 2, 3, and from the class we have created an object, L1, and then we printed it. As you know, this is also a class, so let's print its object and try to print it and see what happens. So here we write phone1 is equal to phone Nokia 3310 2000. Press shift plus enter. Now print phone1 like this, print phone1 and run the cell. Now you can see that it prints something else. So this is also our class, and from this class we've created our object phone1. But when we print it, it shows us the position of this object in memory, or in short, the location of the memory. So as you already know, this L1 is also our object, And by using the print command, it shows us our list in a nice formatted form. How can we do this? Same thing with our phone class, so that it doesn't show us the object's memory location, but instead it prints its attributes. So there are two ways of doing this with the help of the dunder method. So far we've used our dunder method in the form of init method. So in this lecture we are going to see the other two forms of the dunder method. The syntax of the dunder method is the double underscore, then the name, and then the double underscore. This is called the dunder method or the magic method. So when anyone tells you to create a dunder or magic method, then you can create it this way: underscore underscore name underscore underscore. Don't confuse this with a private variable, because in a private variable we write a single underscore before the name of the variable underscore name. Now add a new cell and create our first dunder method in it. As I told you above, there are two forms of the dunder method by which we can print it in a nice formatted manner instead of a memory location. So let's see how we can do this. So here we can create our first form of the dunder method like this: def underscore underscore str underscore underscore self, then hit enter, and on the next line we write pass here. So now let's create our second form of the dunder method, which is written as def underscore underscore repr underscore underscore self, hit enter, and we also write pass here. So these are two ways of writing the dunder methods. Now what will they do? So if you print your object via this method, then it will show you the object list instead of a memory location. So if you print your object via this method, then it will show you the object list instead of a memory location. Here we removed our pass because we want to return something. So as you know, we previously used the dictionary to print our objects, but now we are going to print them with the print method. So for that, here we return f self model self price. Okay, now copy this return line and paste it into our second dunder method. Now run the cell, and here we have already created our object phone1. Okay, so to run the code, comment out this and also this. Alright, now call our phone1 object by using our first form of the dunder method like this, phone1.str. Sorry, it will be written like this: str phone1, like str parenthesis phone1. As you can see, it prints the value. Okay, so let's change the model into a brand in both dunder methods so you can easily get the idea. Let's comment out this second dunder method, and here we print our phone1 object like this: print phone1. Above it showed us the address of the memory, but now you can see it prints phone1 values. So let's see this again. Comment out this dunder method and run all the cells again. Here it shows us the memory location. So now uncomment this and run print phone1 cell. Sorry, we have to run all of the cells, and here we have the phone1 attributes. So let's add the model name too. Write self model. Okay, so here it prints the brand, model name, and price. Now let's try our second dunder method. So uncomment this, okay, underscore underscore repr underscore underscore dunder method, and comment out this underscore underscore str underscore underscore dunder method. So now run all of the code. It prints the brand name and the price here. If you copy the above return code and paste it here, then it will also show the same result like this. Now one question arises in your mind: so if they both are showing the same result, then why do we have two different methods for the same thing? So the reason behind this is that if we want to show some result to our user in a well formatted manner, then we use the str method. Else, if we want to show the result to a developer, then we will use the repr method. So now let's see an example of this. So here, if I want to show the result to some users, then I'll add some text for a good understanding of the user. So for example, here we can add, and the prices. Now let's run this code and see the result. Okay, so as you can see, it's working. Now this is a good representation to show to our users. So we have both methods working here. So it prioritizes the str. Most developers return objects in the RPR method. So here, for example, I created a phone1 object like this, but with the help of RPR method, we don't need to create an object like this. We can do it in our return statement. Return phone, self-brand, self-model, self-price. You can also add quotations here like this. Return phone, self-brand, self-model, self-price. Now run this. Okay, so this is the result of the str method. Now, if I want to print our RPR method, we can do this by commenting down our str method. So there are also two ways of printing an object created in the RPR method. So let's see them one by one. The first way is that we can write print REPR phone1, so it shows us the result. Here you can see the result. So now the second way of doing this is by writing print phone1 dot, okay, REPR parentheses. Now run this, and as you can see, it prints our object here. You can also do the same with the underscore str underscore method like this by changing the REPR into str, so it shows the result. In this lecture, we learned about how to print our object through name mangling, because when we previously printed our object through the print method, it gave us the memory location of the object. And you can see that when we print our list class through the print method, then it prints the well-formatted list. So as you know, the list is by default a class in Python, but you want to do the same thing with our own class. So for that, we've used two ways of doing this with the dunder or magic method. The first way of doing this is with the use of str method, and the second way of doing this is with the RPR method. Both methods will do the same thing, just that the str is used for showing the result to users, whereas the RPR is used for showing the result to developers. So this is also a convention that is used by most professional developers. If you want to print a string in a nice formatted manner so that the user can easily read and understand the text, then you have to use str. And if you want to print your text in an object form to show that to other developers, like if you want to show it to other developers, then you can return your string in an object formatted manner by using REPR like this. So here you can see that it prints the string in an object formatted manner. Alright, so I hope that by now everything is super clear to you. And yeah, like that's pretty much it for this lecture, and now on to the next one. Alright, so in this lecture we'll learn about operator overloading. In the previous lecture we covered the dunder method, which is also known as the magic method, and we also saw that the init method is also a dunder method. So we then discussed the two ways of using the dunder method. The first one is the str and the second one is the REPR. In this lecture we'll see what is operator overloading and how we can use that. Okay, so for that let's write a is equal to 2. Now on to the next line, write b equals 3, and then add c is equal to a plus b. Now print the result by writing print c and hit shift plus enter. The result is 5, which is the sum of 2 and 3. But what happens if we add two lists? So let me show you. Let's first create our first list. L1 is equal to 1, 2, 3, 4, 5. Hit enter, and on the second line create a second list. L2 is equal to 6, 7, 8, 9, 10. Now let's add them. L3 is equal to L1 plus L2, and then print the result like this. Print L3, and as you can see, it combines the items of both lists and gives us the result. If I change the items of 12 like this, 2, 5, 7, 2, and now subtract it from the first list and run this cell, then you can see that it throws an error that says unsupported operand type, which means that the dash is an unsupported operator, but it works for the plus operator. So here you can see that it combines L1 and L2. Okay, so this is our class list and this is our object. So this is also a class list and this is an object. We add these two objects and send our answer to L3. Then we print L3, which combines both lists. Now two questions arise. How can these two objects be combined, and can we also add objects of our class? So because this is the list that is predefined in Python, so does the same thing apply to our created class? Yes, we can do that with our classes by using the operator overloading. In the operator overloading, we add or overload our own information beyond their predefined operational meaning. So let's do it practically. For that, let's create a class with the name phone like this, class phone, and then hit enter. And on the next line, create your constructor like this, def init self brand model price. Now hit enter. On the next line, write self.brand is equal to brand and hit enter. Then on the next line, write self.model is equal to model and hit enter. Then write self.price is equal to price. Now here we create our object by writing phone1 is equal to phone Nokia 11003000. Okay, an error occurs, so let me see what's the problem. Okay, so here I missed the underscore after the init method. Now run this again, and as you can see, it's running perfectly. Okay, let's print phone1 like the phone1 dictionary, the phone1.dict, and hit shift plus enter. So here it prints the phone1's attributes. Now let's make another object with the name of phone2. So phone2 is equal to phone Nokia 16005000 and run the cell. Also print its dictionary like we did above. So phone2.dict and then hit shift plus enter. Okay, so it shows the result. So we have different models and prices for both objects. Okay, so here let's make a method of operator overloading. So for this we write def, and as we learned in the previous lecture about the dunder method, here we use that def add self. So here we have to pass two parameters, self and self2. You can write anything here like self, other. Now on the next line, return self.price plus other price. Now what will this method do? So here the add operator will add our two objects price. In self.price we call phone1 price, and in other.price we call phone2 price. So let's see if it works or not. Run the whole code. Now in the next cell we will add both objects. So phone1 plus phone2. Here it shows the result 8000, which is the sum of 3000 and 5000, as you can see. With the help of the operator overloading, we defined our logic in our add operator. Alright, so now whenever we use the plus operator, then it will add the price of two objects and return the sum. In the same way, you can create a subtract operator overloading method or multiplication operator overloading method. So if you go to the Python documentation and in the exercise 3.3.8, it shows the list of emulating numeric types like add, subtract, multiply, mode, div mode, power, XOR, and OR. With the help of operator overloading, we can change the logic of our operator. So as we saw above, like a list, we have an add operator, and with its help we can add our lists items. In the same way, we can create an add operator overload method for our class, and we can use it for adding our two objects prices as we did earlier. So if you want to create an operator overloading method for subtraction, we can write def sub self other and hit enter. Now on the next line, copy this line of code and paste it here and change the plus into a minus, return self.price minus other price. Here it's adding the prices, and on the next line we'll subtract the prices like this. So phone1 minus phone2, so it returns minus 2000. If we change this 2 to 1 here and vice versa, then you get a positive value. In the same way you can multiply it. So for that, copy the code above and paste it here, then change the underscore underscore sub underscore underscore into multi, and here change the operator into an asterisk. Now here run all of the cells, and in the next cell you can write this phone2 multiplied by phone1 and press shift plus enter. Okay, so it throws an error, so let me see that. Oh, okay, so it's not multi, it's like mul, M-U-L. So now run all of the code again, and here you go. You can see the result in front of you. So it's 15000000. I hope that everything is super clear to you by now. Alright, so yeah, that's pretty much it for this lecture. In the next lecture, we'll talk about polymorphism. But for now, that's it. Alright, and now on to the next lecture. Alright, so in this lecture we are going to cover polymorphism, which is the last and most important topic of object-oriented programming. Let's see what polymorphism is and how we can use it. So polymorphism is not a class, object, method, nor a function. It is just a concept that we use in object-oriented programming. In simple words, polymorphism is the ability to do various things. Anything like an operator or a function that has more than one use, then we call it a polymorph. So the word poly means many, and the word morph means form. This means one thing, which has many forms. So you call it a polymorph. Let's see polymorphism with practical examples. So one thing we have to understand here is how we can find polymorphism in an operator and how we can use that. Here, for example, if you add two numbers like this, 2 plus 3 is equal to 5, that's alright. But when I add two strings like this, 2 plus 3, then it will concatenate them. You can also do this with strings like this, ABC plus ABC, and hit shift plus enter. Then it will show us our concatenated string. It means that we have two forms of a single operator. If we add two integers, then it shows their sum, but if we have two strings, then it concatenates them. This is the concept of polymorphism, where we have one thing with two forms or more than two forms. Now let's use this in our program and see how it works. So in our previous lectures, we learned about operator overloading method and method overriding concept. With the help of these concepts, we are going to learn polymorphism. So here I've created a phone, smartphone, and flagship class. Now let's create their objects. So for creating a phone class object, we write phone1 is equal to phone, Nokia 11003000. Let's create an object for our smartphone class. So we write Samsung1 is equal to Sam. It would be smartphone1 is equal to smartphone, Samsung A7 60,000, 4 gigabytes, 128 gigabytes. Now press shift plus enter. Okay, so it throws an error. I think that I forgot like the rear camera here, so it should be smartphone1 is equal to smartphone1, Samsung A7 60,000, 4 gigabytes, 128 gigabytes, 25 megapixels. Now copy this and make an object for flagship class, then change the class object name into flagship1 and class name into flagship, and add 12 megapixels for the front camera. So flagship1 is equal to flagship, Samsung A7 60,000, 4 gigabytes, 128 gigabytes, 25 megapixels, 12 megapixels. Now run this code. Okay, now here we have to create a method. With the help of that, we'll understand polymorphism. So let's create a new method with def. Here we are creating our operator overloading method like this. So def add self. On the next line, we are going to return the concatenated objects of the phone class as we did in the previous lecture. Just like this. So return f self brand self model name plus. Now copy this return f self brand self model name plus f self brand, self model name, and paste it here. So here we have to pass one more parameter, def add self other, and change this self into other like this. So return f self.brand self.model underscore name plus f other.brand other.model underscore name. Now run the cell by pressing shift plus enter. Okay, so here an error occurs because I forgot to put the last inverted comma. Now run all of the cells again. So in the new cell we'll use our flagship one and concatenate it. Okay, so for that you have to make another flagship object like this. So flagship 2 is equal to flagship Samsung A8 4000 2 gigabytes 64 gigabytes 22 megapixels 10 megapixels. Run the cell, and on the next line concatenate both flagship objects like this, flagship 1 plus flagship 2. As you can see here, it prints Samsung A7 and Samsung A8. So it concatenated our two objects. As you know, according to MRO, our program first goes to the flagship class. It didn't find the method from here, so it goes to the smartphone class. It also didn't find the method there, so it goes to the phone class, and it finds the method here. So it runs the method from there. Now I'll copy this method and paste it here and also here. Now I'm going to change the working of this underscore underscore add underscore underscore method in the smartphone class and in the flagship class. So here in the flagship, I will only concatenate the price of both objects like this. Return self.price plus other.price. Now change this in the flagship class. Here we'll concatenate the megapixels of the rear cameras. To do that, right, return self.rear underscore camera plus other.rear underscore camera. Now run all of these codes. Here, our add method has a different purpose. In smartphones, our add method also has a different purpose, and in phone class, our add method also has a different purpose. So now let's use these methods. At first, we are going to run our flagship add method. Run all of these codes again. Here you can see that it concatenates our rear camera values. So here we have to give some space, then run all of the code again. Because these two are strings, that's why they concatenate with each other. Let's create our second object for the smartphone class. So to do this, copy the above code and paste it into a new cell and change the values like this. Smartphone 2 is equal to smartphone, BlackBerry, XYZ, 90,000, 6 gigabytes, 128 gigabytes, 25 megapixels. Now in the smartphone add method, it will add the price of both objects. Now run all of the code and in the new cell add both objects just like this. Smartphone 1 plus smartphone 2, then press shift plus enter. As you can see here, it adds both the prices of smartphone 1, which is 60,000, and smartphone 2, which is 90,000, and gives us 15,000 as a result. So now let's check the add method of our phone class. For that, we have to create an object like this. Phone 2 is equal to phone Nokia 1600, 4000. Now run all of the cells. Oh, okay, so an error occurs. Let me see that. Run the cells again. Yes. Here it should not be in the second line. So now run the code again. Now in the next cell we write phone 1 plus phone 2. Okay, so it concatenates Nokia and 1100 with Nokia and 1600. So here we can see these three lines. On the first line, flagship 1 plus flagship 2, it concatenates the rear cameras of both objects. Now here on the second line, smartphone 1 plus smartphone 2, it adds their prices. And on the third line, the brand and model of our phone class objects, phone 1 plus phone 2 are concatenated. As you can see here, we have one operator, but we are using it in three different ways. So this is an example of polymorphism. I hope that everything was very clear to you and that there was no confusion regarding this topic. So to conclude this lecture, polymorphism is a concept in which a single operator or method can be used in different forms. Here, for example, I've created a NAD method with the plus operator for these three classes and used them in three different ways. So for flagship class objects, it works differently. And for the smartphone class objects, it also works differently. And for the phone class objects, it equally works differently. So this is an example of polymorphism, and this is the last topic of object-oriented programming in Python. Alright, so I hope that everything was super clear to you and that you understood all the topics that we covered in this object-oriented programming series. So that's pretty much it for now. And now on to the next lecture. Alright, so in this lecture we'll do a project on object-oriented programming in Python, in which we'll cover all the topics that we've learned so far. So first of all, let me give you an introduction to this project. In this project, we'll create a library in which we include the name of the owner of that library and the name of all the books available in the library in a list format. After that, we'll create some functions like one to display books and one to add books and also to lend books and another to return them. So these are all the functions we'll cover in this lecture, and in the next lecture we'll execute them. Okay, now let's make a class with the name library, like this, class library. Now hit enter, and in the next line we write def init self list name. Now hit enter. I just created a constructor in which I passed the list for the list of books and the name for the name of the person who owns the library. Now in this line we write self.booklist is equal to list. Now hit enter. In the next line, write self.name is equal to name. Again, hit enter. Now in the next line, we'll create a dictionary which includes the person's name who lends the book and the book name which is lent by that person, and that would be stored. Alright, so to do that, let's write self.lendict is equal to curly brackets and hit enter. Now in the following line, create a function with the name display like this, so def display. So here we don't need to execute this piece of code. We'll execute all the code of this cell at once. So okay, here we are creating a function named display books like this. So def display books self. Now hit enter, and in the next line we print the name like this. So print f quotation mark self.name curly brackets. Okay, so we have to close the brackets as well. Okay, here we write the text for a better user experience, so other users will understand the program's purpose. So here we write print f self name. We have the following library in our library, and then close the bracket and hit enter. So in the next line we initialize our SNO variable for the book serial numbers, like SNO is equal to 1. Now in the next line we use a for loop to display the list of books like this. So for book in self.booklist and hit enter. In this line we print our SNO and book like this. So print f quotation mark SNO book. Now hit enter. In this line we write SNO plus equals 1 for incrementation purposes. So that's what we do. Now let's create our second function with the name lendBook like this. So def lendBook self book. This is our instance method which shows the lend book name. So in the next line we check if this particular book is present in our list or not. So to do this we use a if statement like if book in self.booklist and hit enter. In this line we check if our book is already being lent to another person or not. So if it was already lent to another person, then we can't lend the same book to other people. So to do this we write if book not in lend dict, hit enter, and in this line write self.leddict.update. So here we use the update function which is used to update the dictionary. So now here we write book colon self.name in the update function like this. So self.leddict.update brackets book colon self.name. So we use this self.name. Okay, so here our update function updates the dictionary with the book name which is lent by any person. Okay, now in the next line we show the message to the user like this. So print lender book database has been updated, you can take the book now, and hit enter. In the following line we use the else statement. So if the book is present in the len dict, then it will show the message to the user like this. So print f quotation mark book is already being used by self.lend dict book. Okay, we close brackets. So because we have only one piece of every book present in our library. Hence, if any other person lends any book, it shows this message. So hit enter, and in the next line we create another instance method like this. So def add book self book, hit enter. So in the next line we'll append our book list like this, self.booklist.append book, hit enter, and in the next line write print book has been added to the book list. Now hit enter, and in the next line let's create another method with the name return book like this. So def return book self. So this is also an instance method. That's why we write here self, because we may use these self keywords in the future. So here we write def return book self book. Now hit enter. Okay, now we can check if this book is present in the book list or not. So for this we write if book in self.booklist, then hit enter, and in the next line write pass. So in the next line we use the else statement and then print a message like print this book does not exist in our database. So here we can also write related to our database instead of exist in our database. Now here we have to remove pass and write another if statement. So to check if our book is present in the len dict like this, if book in self.lendict.keys, now enter to the next line, and we use a pop method like this. So self.lendict.pop book, now hit enter, so it will pop out the book from lendict. In the next line we use the else statement, and in that one we return a message like this. So print f quotation mark this book is curly brackets book not in use close brackets. So the purpose of this function is to get the book back from the user who lent that book and checks whether this book was from our library or not. And we also put another if statement here to check whether this book was lent through this library or not. So if not, then it will show a text from the else statement. Now let's execute the cell and check whether it's working. So before that, let's create our library object with the name Ben library. Okay, sorry, here I've written the wrong spelling. It should be like library. Now copy this class name and paste it here. So Ben library is equal to library. So here we pass the list of books which we have in our library like this. So Ben library is equal to library, Python, Java, data science, web scraping, data mining, Ben. So here we wrote the book names and the owner name of the library. Let's run this by hitting Shift plus Enter. Okay, so here we have an error that occurs. It says the library is not defined. Alright, so let me check this error here. It does not find our name attribute. Okay, sorry, here it would be like equal, not dash. So run now all the code again. Okay, so it's working now. Let's print the dictionary of our library like this. So Ben library.dict and run this cell. Alright, so it shows the name of all the books and the name of the library owner. Okay, so now let's run all the functions one by one. So the first one is display books to check that we have like to write Ben library.display books, and now run this cell. Okay, sorry, here we have to put the round brackets like this. So Ben library.display books. Now hit Shift plus Enter. So as you can see, it shows the result with the serial number. Okay, so now let's run our add book method like this. So Ben library.add book. Okay, so here we have to add a book name. So I'm adding React Native here, Ben library.add book React Native. Now run the cell. So as you can see here, it shows book has been added to the book list. Like that's the message that we get. Now let's see our lend book method. So for that you have to write Ben library.lend book data science John. Okay, so here we wrote the name of the book and the name of the person who lent that book. So for that we have to add name here. Okay, so it can take the name of the person as a parameter, and here we have to change it to name also. Alright, so let's run all the code again. As you can see here, it shows us the message, and you can also double check it by printing the list of currently available books in our library like this. So Ben library.dict. Now run the cell, and as you can see here, it shows the result that John lent this data science book. Okay, so let's lend one more book like this. Ben library.lend book data mining Michael. So now run this cell, and here it shows the message, and you can confirm it by rerunning this Ben library.dict. Alright, so here you can see it that it shows like data mining. The data mining book was lent by Michael. Okay, so here we are going to use the return book method like this, Ben library.returnBook data mining, and now run this code. Okay, so I forgot to put the return message in our return book method. So for that we write print, okay, thank you, book is received, and now run all the code again. Okay, so here we get an error. Let me check this. Okay, so run all the cells again, and as you can see here, it shows the message. Okay, now let's see if our other statements are working. So to do that, we have to change our book name here into something which is not present in our library. So here I will change it into data and run this cell. Okay, here it shows the message, like this book is not related to our database. Okay, now if I return the data mining book, then it shows the message. Oh, okay, so this sentence shows no meaning here. Let's change it into something meaningful, like a meaningful sentence. Okay, so I have to remove the is and insert it after the book name, right? Like, let's now run all the code again. So as you can see here, it shows a thank you message. And now let's rerun this code. And here it shows that this book, data mining, is not in use. Because Michael already returned this book, like that's why. Okay, so that's it for this lecture. We can see like how these methods work, and in this lecture, like we've only created our library class and some methods commonly used in any library management system. In the next lecture, we'll dive deeper into the different elements of this project. All right, and now on to the next one. Okay, OOP project part 2. Alright, so let's continue our library management project. In the last lecture's code, there were some mistakes that we had to correct before proceeding further. Okay, so here the first mistake is in the spelling of books. I have to remove one O from this, and the second mistake is the name of the variable we wrote. It was like lendict, and here we wrote it as lenddict. So I removed the D from it. And the last mistake I made in the previous lecture was in the lendbook method. So I forgot to write an else statement, which prints the message to the user if he or she demands any book that we do not have in our library. Okay, so for that write else, then press enter, and in the following line write print. This book is not related to our database. Alright, so these are all the corrections. Now let's run all the cells again and see if it's working or not. Okay, so here an error occurs because I wrote the wrong spelling. So let's correct this. Now run all these cells, and here is also a spelling mistake. So let's correct that also. And now run the remaining cells. Okay, so now our program is running perfectly. Now in this lecture, we'll dynamically execute this program, which means that this program runs in a continuous loop. So to do that, you have to select the markdown option from this drop-down menu like this, and after selecting that option, I write execution work in the next cell. So let's change this markdown into a heading from the above drop-down menu like this. So now it becomes our heading, and Python can read it as a heading and ignore this piece of code. Okay, now generate multiple cells. So I think that's enough for our code. Okay, so from here, we'll continue our execution code. So to do that, first you have to create a main function like this. So if main is equal to main. Okay, now we're going to initialize our library object. So we can also write object here, but I prefer writing meaningful names like Ben library is equal to library brackets, square brackets. Okay, here I have to put my list. So to do that, I'll copy a list from above. Let's copy this whole line and paste it here. So it's our object with the name Ben library, with the owner name Ben. And now in the next line, I used the while true statement for looping our program. Now hit enter, and in the next line, print a statement like this. So print welcome to the Ben library.name library. Enter your choice to continue. Now hit enter, and in the next line, print the name of options for the user to choose like this. Print one display books. Now let's make 4 copies of this. Now let's change now the 1 to 2, and here 3, and here it will be 4. Now change display books into lend a book at the second option, and at the third one it would be like add a book, and at the fourth one it would be change into return a book. Alright, so these are our print statements, which would be shown to the user, and the user has to select an option from them. Now in the next line we are going to take input from the user and store it in our user choice variable like this. So user underscore choice is equal to input. Here I use the input because I have to pass a string as a value. So you may know already that input takes values as a string. Okay, alright, so in the next line I'll write an if statement to check whether the user selected the correct option or not. So for that, I write if user choice not in 1, 2, 3, 4. Now hit enter, and in the next line write print, please enter a valid option. Okay, so in the next line write continue. If the user enters the wrong number, then it will continue this above if statement. Now in the next line we write our else statement like this. So else, hit enter, and in the next line write user underscore choice is equal to int user choice. So it will convert our user choice string into an integer. Okay, so let me correct the syntax of my code. As you can see, it generates errors because my code indentation is wrong, so I have to arrange the syntax of my code. Okay, I think it's okay now. So here we use the if statement to get the user underscore choice. If a user enters like the wrong number, then he gets this message, please enter a valid option. Then this loop will run again. But if the user enters like a valid value, then our else statement runs. Okay, so now hit enter, and in the next line write another if statement. So if the user choice is equal to 1, here our first option will be display books. For that we have to write ben library dot display books as we wrote above. Okay, now move on to the next user choice for the len book option. So to do that we have to write elif user underscore choice is equal to 2. Then hit enter and write book is equal to input, enter the name of the book you want to lend. Now hit enter, and in the next line write user underscore name is equal to input, enter your name, again hit enter, and in the next line write our len method. So ben library dot lend book user book. Let me check if it's the same pattern as I wrote above. Oh, okay, so no, it's not. It's book in the first place and then name, so we have to follow this same pattern here as well. So let's change this. Okay, the indentation error again occurs, so let me fix that first. Okay, so now like one more error occurs here. We can see it later. For now, let's focus on the if-else statement. In the following line, write elif user choice is equal to 3. So for our add book method, now hit enter and copy this line of code and paste it into the next line and change the lend into add like this. So book is equal to input, enter the name of the book you want to add, then hit enter. In the next line write our add book method like this. So ben library dot add book. Okay, so in the next line we'll create our fourth option like this. So elif user underscore choice is equal to 4, hit enter, and now copy this code and paste it in the next line and change the add into return like this. So book is equal to input, enter the name of the book you want to return. Now in the next line we use our return book method like this. So ben library dot return book. Okay, and then last thing, in the else statement we print for a user like this. So print not a valid option. Okay, now our program runs in a loop. So here we need two more options for the users. The first one is quit, and the second one is continue, because users can quit our program and other users can continue with our programs. So to do that we show a message like to the user like this, print press Q to quit and C to continue. And now in the next line write user underscore choice is equal to quotation marks, then hit enter. So in the first line write while user choice exclamation mark equals C, and user choice is different than Q. Now in the next line write user choice is equal to input and hit enter, and in the next line write if user choice okay, so let's make this user choice too, because we already used user choice above. So let's change it here and here and here as well. Okay, great. So now write if user choice 2 is equal to Q, then hit enter, and in the next line write exit. Now if a user enters Q, it will terminate our program. Okay, now in the next line write elif user underscore choice is equal to C, then hit enter, and in the next line write continue. So if the user enters C, it will continue. our program. Okay, so now we have to solve this error. So let me check. Okay, so here it will be like name, not main, as you can see. So it executes our code, and you can see that we have passed the Ben as an owner name. So it returns that. Now let's check if it's working perfectly or not. Okay, so here I typed 1 and then press enter. You can see here that it returns the book names which are present in our library. So now if I type C here, then it comes back to my library methods. Now I type 2 and it asks me the name of the book which I want to lend. I want to lend the React book. So now it's asking my name, but we don't have a React book in our library, so we have to solve this issue. Let's check it by entering any name like Sohel. Okay, and now it throws an error. So let me check this first. Okay, so here it would be like username, and now run this cell again. All right, so let's check our program again, and here we need to type 2. Okay, now we have to enter the book name like React, then it asks to enter my name. Let's type Sohel here and hit enter. As you can see, it returns us a message. So this book is not related to our database. So this is working perfectly. Okay, so let's press C here. It will continue our program. Let's check it one more time. And here I give 1, and here I enter Sohel. As you can see, it's working perfectly. Okay, again, continue our program by entering C, and now check which books are present in our library. So to do that, enter 1 here. Okay, so it shows us the result. And now lend 1 book from our library. So here, enter C to continue, and now choose 2, like the 2 option, and here enter Python, and now here I type Sohel. Okay, let's check if it's working or not. Alright, so as you can see here, it returns the message that the lender book database has been updated. You can take the book now. Okay, so let's continue our program and now check our add book option by choosing the option 3. So here it asks me to enter the book name, which I want to add. Okay, so here I want to add the React Native, and now hit enter. Alright, so it shows the message that the book has been added to the book list. And now enter C to continue. Alright, so let's choose option 1 to see if our book is added or not, and yeah, here you can see the React Native is added here. Now let's check our last function, like return a book, by typing 4. Okay, so it's asking me to enter the name of a book which I want to return. So I write here Python. Okay, so now let's check with the other name first, like here I write data scraping. So let's see what it returns. Yeah, it returns this book is not related to our database. Okay, so it's working fine. Now continue our program by entering C, and here we choose option 4 again. And now here I'll write the real book name like Python, which we have to lend above. And as you can see here, it shows the book received message. Okay, so this is the end of our OOP lecture series. It's the end of our online program. We have learned a lot in this OOP series. I hope that everything is super clear to you by now. So let's recall some of the names of the topics that you've studied so far. Like in the beginning, we learned about the introduction to object-oriented programming. Then we created our first class, and after that we did an exercise on the class topic. Then we moved on to the method topic, and we did like 2 exercises on that. And then we covered the class variables topic and the object techniques. Then we studied the class method and then the static method, and we did an exercise on that static method. And then we learned about abstraction and encapsulation. And then we covered inheritance and multi-level inheritance. We have also covered method overriding and MRO. And after that, we've seen the is instance and the is subclass methods. And then we have also seen multiple inheritance, the naming convention, the name mangling, the dunder methods, the operator overloading. And then lastly, we saw the polymorphism. Alright, so I hope that by now you have a great understanding of all these different topics which we've studied so far. Alright, so that's it for this course. That's it for now. My advice to you, cut. Okay, so I hope that by now you have a great understanding of all these different topics which we've studied so far. So that's pretty much it for this course. That's pretty much it for this lecture. I wish you the best of luck, and always remember that you should never ever stop learning. Never ever stop learning. I wish you the best of luck and hope to see you soon.